What if humanity isn't Earth's first advanced civilization? Imagine for a moment that our skyscrapers, our cities, and even our entire history are just one layer in a cycle that has played out again and again over millions of years. It sounds like pure science fiction, the kind of wild theory you'd expect to hear in a late-night conspiracy forum. But when you start digging into the scientific record buried deep in rocks, ice, and even the bottom of our oceans, you start finding strange anomalies, odd fingerprints that don't quite add up. Evidence that suggests maybe, just maybe, we aren't the pioneers we believe ourselves to be. Earth is an expert at hiding its past. In just a few thousand years, forests reclaim cities. In a few million, entire coastlines vanish into the sea. Push that timeline to tens of millions of years, and even the boldest monuments crumble into dust, recycled by tectonic plates, or swallowed by the ocean. If a civilization had existed long before us, how much evidence would really remain? Almost nothing. But almost nothing isn't the same as nothing at all, and the few clues that survive are strange enough to make even hardened scientists scratch their heads. There are nuclear signatures locked inside billion-year-old rocks, objects that look manufactured, yet date back to epochs when humans didn't exist. Ancient carbon spikes in the atmosphere that resemble industrial pollution, but appear millions of years before the industrial age. And then there are the chilling questions we can't escape. If dinosaurs ruled Earth for over 160 million years, why do we assume they never built anything greater than nests? If Mars once had oceans and air, who's to say intelligence didn't rise and fall there too? The more you look, the harder it becomes to shake the thought. What if history isn't linear, but a loop? And if Earth has already seen civilizations come and go, the real question is, how long do we have before the same fate reaches us? 250 million years ago, the world almost ended. Long before dinosaurs even began their reign, Earth went through a cataclysm so devastating that it wiped out nearly everything alive. It's called the Permian extinction, or more dramatically, the Great Dying. Imagine a planet teeming with strange, alien-looking creatures, giant insects buzzing through the air, reptilian beasts roaming across vast continents, seas filled with bizarre fish and sprawling coral reefs. Then, in what is almost a blink of geological time, 96% of all species vanished. Entire ecosystems collapsed, forests withered, oceans turned into dead zones. The Earth for a moment looked like a barren rock all over again. Scientists have long debated what caused this unimaginable catastrophe. Some blame massive volcanic eruptions in Siberia that spewed toxic gases into the atmosphere, creating a runaway greenhouse effect. Others argue that asteroids may have slammed into Earth, similar to the impact that ended the dinosaurs millions of years later. But here's where the mystery deepens. The timing and speed of the Permian extinction don't entirely fit the natural explanations we're so quick to accept. The chemical signatures in the rocks reveal sudden spikes in carbon dioxide, methane, and even traces of chemicals that look unnervingly similar to the kind of pollutants you'd expect from industry. And the extinction didn't play out slowly across millions of years as natural events usually do. It unfolded in as little as 20,000 years, a blink when compared to Earth's long timeline. In cosmic terms, that's like watching an entire biosphere collapse in fast forward. This is where the unsettling questions begin. What if nature wasn't the only hand at play? What if something else, something intelligent, left its mark on the planet long before us? Imagine a civilization, not human, not even mammalian, that had technology advanced enough to manipulate the environment, perhaps even recklessly. A civilization that burned through its resources, altered the atmosphere, and triggered a chain reaction it couldn't control. The geological record shows us devastation, yes, but it also whispers of possibility, an ancient industrial age erased by time. Skeptics roll their eyes at the idea, pointing out that we have no concrete artifacts, no buildings, no machines, and that's true, at least none that are immediately obvious. But pause and think about what happens to our own world if humanity disappeared tomorrow. Within a century, our cities would crumble, skyscrapers collapsing under the weight of neglect. In 1,000 years, forests would reclaim nearly everything. In 1,000,000 years, glaciers and tectonic shifts would grind steel, concrete, and glass into dust. Give it 10 million years, and almost every trace of us would be gone. Now stretch that to 250 million years, the gap between us and the Great Dying, and ask yourself honestly, what would be left? The sobering truth is almost nothing. The fossils we cherish today, delicate imprints of leaves, shells, or bones, are rare flukes, preserved only under perfect conditions. If an advanced civilization had thrived in the Permian period, the odds of us stumbling upon a fossilized smartphone, skyscraper, or spaceship are close to zero. But chemistry leaves traces: carbon isotopes, uranium signatures, and unexplained spikes in metals. They linger in the rocks like ghostly fingerprints. And some of those fingerprints don't look natural. Here's something even stranger. Certain layers of rock from around the time of the extinction contain elevated levels of nickel, copper, and lead metals that in our own time are deeply tied to industry. Scientists argue these could be explained by volcanic activity, but the distribution patterns are inconsistent, resembling the scatter you'd expect from widespread smelting or industrial pollution. Could it be coincidence? Absolutely. But is it enough to rule out another explanation? Not so easily. Let's go even further. In the oceans, the extinction left behind chemical anomalies that look eerily similar to modern dead zones, areas where fertilizer runoff and pollution choke marine life. The seas of the Permian collapsed into lifelessness in a way that mirrors our own ecological crises today. Was it volcanic gases poisoning the waters, or was it something disturbingly familiar, like industrial waste on a planetary scale? Now, picture this. An ancient civilization that rose not from primates but from creatures we would barely recognize. Maybe reptilian, maybe amphibian, maybe something stranger still. They develop technology, they manipulate their environment, they flourish. But like us, they push too far. Their expansion disrupts ecosystems, their industries belch gases into the air, and eventually the balance tips. Earth itself turns against them. Their cities crumble, their species wither, and within a geological blink, they vanish, leaving only the faintest scars in the rocks. What we see as natural disaster might in reality be the echoes of their downfall. It's an unsettling thought, because it forces us to look in the mirror. The great dying becomes less of a mystery and more of a warning. Could history already be repeating itself, millions of years later with us in the starring role? Our carbon emissions are skyrocketing, our oceans are heating, and dead zones are spreading just as they did back then. Maybe the Permian wasn't just an extinction, it was a cycle, one that civilizations fall into again and again: rise, expand, destroy, collapse. Then the slate wipes clean, and the planet starts over, ready for the next contender. Skeptics argue it's all fantasy, but even some scientists have allowed themselves to wonder. Gavin Schmidt and Adam Frank, researchers from NASA and the University of Rochester, once asked a provocative question: if an industrial civilization had existed long before humans, how would we know? Their conclusion was both fascinating and chilling. We probably wouldn't. The evidence would be subtle, indirect, and hidden in geochemical oddities, the very anomalies we already see in Earth's record. They dubbed it the Silurian hypothesis, named after a race of reptilian scientists from old British science fiction. It's meant partly as an intellectual exercise, but the more you think about it, the less absurd it seems. The Permian extinction might have been Earth's first great warning shot, or its first recorded collapse of a civilization far older than we dare imagine. And here's the kicker: if we accept even the slightest possibility that intelligence has risen and fallen before, it means humanity isn't special for being first. It means we're special only because we're here now. But if history is cyclical, that raises an even scarier question: how long do we have before the cycle claims us too? And this is just the beginning. Because if the great dying leaves us with unsettling chemical fingerprints, what comes next in Earth's geological record is even harder to explain. Strange nuclear signatures buried in ancient rock formations, anomalies that seem to scream of technology far older than humankind. The deeper you dig, the stranger it gets. And what comes next might just turn everything you thought you knew about history upside down. If the Permian extinction hints at something unnatural in Earth's past, then the discoveries in a quiet corner of Africa take that possibility and make it impossible to ignore. Deep in the tropical region of Gabon, scientists uncovered something so baffling that, when first revealed to the world in the 1970s, even nuclear physicists struggled to believe it. Buried beneath the ground at a place called Oklo lies evidence of nuclear fission, controlled nuclear reactions, that by all logic should have been impossible on Earth billions of years before humans ever appeared. Here's what makes this discovery so unsettling. When French scientists began analyzing uranium deposits at Oklo in 1972, they noticed something strange. Natural uranium contains about 0.72% of the isotope uranium-235, the exact material required to power nuclear reactors. But the ore samples from Oklo didn't match that figure. They were depleted, as though large quantities of U-25 had already been used up. At first, officials worried it meant someone had stolen the uranium for weapons. But that explanation didn't hold up. These deposits weren't recent. They were ancient, embedded in rock nearly 2 billion years old, and the only way for those deposits to lose so much U-25 was if they had undergone long sustained nuclear chain reactions, just like the ones we manufacture in power plants today. Scientists scrambled for answers, eventually concluding that Oklo must have been the site of a natural nuclear reactor. The conditions at that time, slightly higher concentrations of uranium and the presence of groundwater, could in theory have allowed self-sustaining nuclear fission to occur. They called it a freak of nature, an incredible geological coincidence. And yet, the deeper they looked, the harder it became to wave it off as purely natural. The Oklo reactors, as they came to be known, weren't just one isolated pocket of fission. There were 17 separate reactor zones spread across the area. 17, each one operating intermittently for hundreds of thousands of years, generating heat, releasing energy, and leaving behind spent fuel and byproducts exactly like a man-made power plant would. But the strangest part isn't that the reactions happened, it's that the waste products, the dangerous isotopes left behind after fission, didn't spread and contaminate the surrounding environment. Somehow they stayed neatly contained within the rock, locked away for billions of years. Even by modern standards, this level of containment is impressive. Our own nuclear waste storage efforts pale in comparison, often plagued by leaks and contamination. Yet here was a natural reactor that not only functioned but also stored its waste perfectly for eons. Some scientists suggested that this was sheer luck, an accident of geology. But others couldn't help but ask the forbidden question, what if it wasn't an accident at all? Imagine for a moment a civilization that mastered nuclear energy 2 billion years ago. To us it seems impossible, because 2 billion years ago, multicellular life on Earth was only just beginning to appear. But what if we're wrong about that? What if intelligence rose earlier than we think, and what we're left with is not simply a natural curiosity, but the ruins of their technology, disguised as a geological anomaly? To entertain that idea is to break the neat timeline we've built for Earth's history. But Oklo refuses to be neatly explained away. Critics argue that natural reactors are theoretically possible, and that Oklo simply represents an extraordinary example. But the precision is what nags at the imagination. For nuclear fission to sustain itself without exploding uncontrollably or fizzling out, the balance has to be just right. The ratio of uranium, the presence of a moderator like water, the geological configuration. It's like finding a series of campfires that lit themselves, burned steadily for thousands of years, and then put themselves out without burning down the forest. Possible? Sure. Likely? That depends on how willing you are to accept coincidences, stacked on top of coincidence. And then there's the matter of plutonium. Plutonium-239, the stuff used in nuclear weapons, doesn't occur naturally in significant amounts. It has to be created inside reactors, when uranium-238 absorbs neutrons. And yet, traces of plutonium have been found at Oklo. Let that sink in. A naturally occurring nuclear reaction supposedly ran long enough, and precisely enough to generate plutonium, the very element we associate with our deadliest technology. That doesn't just sound like a natural quirk, it sounds like engineering. Some researchers have tried to close the case by saying that Oklo proves natural nuclear reactors are possible, but that still leaves the door open to something far more provocative. If nature can spontaneously produce nuclear reactors with waste sealed away better than anything humans have ever built, then doesn't that itself seem almost engineered? As if Earth itself, or something on it, once had the capability of harnessing energy far ahead of its time. And here's where the mystery gets even deeper. When scientists compared the isotopic ratios of the elements at Oklo to those produced in modern reactors, the similarities were uncanny. The distribution of certain rare isotopes like neodymium and ruthenium matched what we see in reactors today. Not only had fission occurred, it had occurred in a way strikingly similar to our own technology. That means either nature is far more capable of mimicking our designs than we ever imagined, or we're looking at evidence of something that was designed long before us. Now, consider the implications if this were artificial. It would mean that billions of years before humanity existed, Some intelligence, whether from Earth or beyond, was experimenting with nuclear power. Their reactors eventually shut down, their civilization vanished, and time buried their achievements beneath layers of rock and history. All that remains is the faint radioactive scar in the ground, which we now scratch our heads over and call a natural reactor. To some, that sounds like fantasy, but to others, it's no more fantastical than the idea that fire started itself 17 times in perfect conditions, burned evenly, created plutonium, and then tidally cleaned up its mess. And even if we accept the natural explanation, the Oklo reactors force us to grapple with a haunting truth. Nuclear energy is not some modern invention. It is embedded in the very fabric of the planet, waiting to be discovered, waiting to be unleashed. That begs the question, was humanity's discovery of fission in the 20th century really a first, or was it a rediscovery? Did we stumble upon a technology that once doomed another civilization, unaware that we were walking the same dangerous path? What makes Oklo even more chilling is how it lines up with our own anxieties. Today we wrestle with nuclear power as both salvation and threat, an energy source that could sustain our future or obliterate us in war. The evidence at Oklo is like a time capsule, whispering across the ages. This has happened before, whether natural or artificial. The reactors stand as proof that nuclear fire has burned on Earth long before us, and it may burn long after we're gone. And just when you think Oklo might be an isolated curiosity, you begin to see the pattern. Because around the world, scattered in different eras and strata, there are other anomalies, traces of metals, isotopes and objects that shouldn't exist where they do. Scientists dismiss many as errors or hoaxes, but some remain stubbornly unexplained, and that's where the mystery pulls us deeper. Because if nuclear reactors could exist billions of years ago, what else might have existed alongside them? What other impossible artifacts are waiting to be uncovered? The story of Oklo isn't just about uranium and rocks, it's about perspective. It forces us to question the neat, linear story of human progress. It makes us ask whether we are truly unique, or simply the latest inheritors of knowledge that flares up again and again in cycles of rise and collapse. And it reminds us of something uncomfortable. If there was another civilization before us, they mastered power, but didn't survive it. Their fingerprints remain, but their voices are gone. And maybe that silence is the loudest warning of all. Because if nuclear energy existed once before, and civilizations can vanish without a trace, what else has been erased by time? The answers lie in the rocks, in the anomalies scattered across Earth's history, and some of them are even stranger than nuclear reactors. Artifacts buried in coal seams, iron cubes embedded in stone, objects that scream of intelligence in a world where none should have existed. And when you hear about those, it becomes harder and harder to dismiss the possibility that we are not the first intelligent beings to walk this planet. For over 160 million years, dinosaurs ruled Earth with an authority unmatched in the animal kingdom. They dominated every environment, from vast deserts to sprawling forests, from shallow seas to towering mountains. And yet, in our modern imagination, they are often reduced to mindless monsters or oversized lizards, stumbling through their prehistoric world. But what if that perception is wrong? What if some dinosaurs were not only intelligent, but capable of behaviors we associate with civilization? It's a question that pushes against everything we think we know about life on Earth. Consider the size and complexity of some dinosaur brains. Triceratops, a massive herbivore weighing several tons, had brains comparable to modern elephants. Elephants are known for social complexity, memory and problem-solving abilities. Could Triceratops have exhibited similar intelligence? Velociraptors, on the other hand, were pack hunters, coordinating with one another to trap prey, demonstrating strategic thinking and communication. And then there are species like Parasaurolophus, whose intricate crests may have been used to produce complex sounds for communication. The fossil record alone hints at creatures far more socially sophisticated than we give them credit for. Now, stretch your imagination. Imagine if these social and cognitive abilities evolved further, leading to advanced problem-solving, tool use, and perhaps even early forms of technology. For millions of years, dinosaurs had the time, the resources, and the ecological dominance to experiment with increasingly complex behaviors. Unlike humans, who spent tens of thousands of years as hunter-gatherers before inventing agriculture, dinosaurs had a stretch of uninterrupted dominance lasting hundreds of millions of years. That's nearly 1,000 times longer than the span of human civilization. In that time, even incremental advancements could accumulate into something remarkable. Of course, skepticism is natural. There is no direct evidence of dinosaur cities, machinery, or written records. Fossilization is rare and selective. Entire ecosystems vanish without a trace. Urban constructions would be especially hard to detect, as sedimentation, erosion, and tectonic activity could obliterate the smallest sign of infrastructure. But here is the chilling part. The longer dinosaurs thrived, the more likely it becomes that subtle chemical or geological traces could hint at intelligence long before human eyes could detect them. Imagine coordinated agriculture leaving signatures in soil chemistry, or controlled fires altering carbon isotope ratios in sediments. These are precisely the kinds of indirect fingerprints that survive for millions of years, even when bones and buildings do not. Some researchers have entertained this idea as a thought experiment, but it's not without precedent in the natural world. Birds, the closest living relatives of dinosaurs, demonstrate astonishing intelligence today. Crows, for example, fashion tools, recognize human faces, and engage in sophisticated social strategies. Parrots can mimic speech, solve puzzles, and even exhibit signs of reasoning. Extrapolate these behaviors backward over 65 million years of evolution, and it becomes conceivable that at least some dinosaur species could have developed comparable or even superior cognitive ability. Beyond biology, consider the ecological advantages dinosaurs possessed. Many species grew to enormous sizes while remaining herbivorous, suggesting sophisticated strategies for managing resources and energy intake. Some species migrated in vast coordinated groups, navigating complex terrain over thousands of miles. Social structures, communication networks, and environmental manipulation, these are the hallmarks of civilizations, even if we cannot recognize them in their fossilized remnants. And yet, we assume that because dinosaurs did not leave obvious cities, they could not have been intelligent. That assumption may reflect more about our limited perception than reality. Fossilization is brutal in its selectivity. Fossils form only under precise conditions: rapid burial, low oxygen, and minimal disturbance. Most urban or technological structures would decay before they could be fossilized. Even on modern Earth, our cities and infrastructures erode quickly without maintenance. Consider what 2 million years of unchecked decay can do. Steel rusts, concrete crumbles, plastics fragment, and electronics corrode into unrecognizable dust. Multiply that by tens of millions of years, and the odds of finding a recognizable artifact from any dinosaur civilization approach zero. Yet, indirect evidence, chemical signatures, unusual isotopic ratios, anomalies in sediment layers might survive if we knew how to look. Some anomalies already challenge conventional explanations. Geological strata reveal sudden shifts in carbon levels, unusual metal distributions, and fossilized structures that defy natural formation processes. Could these be the remnants of a civilization lost to time? Perhaps early civilizations, if they existed, didn't need the trappings we expect. They may have lived in symbiosis with their environment, building structures from organic materials that decayed completely. Their cities could have been subterranean or camouflaged within forests, their tools perishable, their energy sources derived from biochemistry rather than combustion. Everything about them would vanish under the relentless sweep of geological time. And then there's the broader picture. Mass extinctions are far more than natural events. They are snapshots of ecological vulnerability. The Permian extinction, as previously discussed, happened astonishingly fast. Could an intelligent species have played a role intentionally or inadvertently? It's a provocative idea, but not inconceivable. A civilization capable of manipulating energy or ecosystems, however primitively, could have triggered environmental cascades beyond their control. Perhaps the very intelligence that allowed them to rise contributed to their fall. This mirrors our own current predicament in subtle, terrifying ways. Think also about their potential for culture and learning. Fossilized nests suggest complex reproductive behaviors. Some species meticulously arranged their eggs, protected them in communal nurseries, or transported them across vast distances. These behaviors indicate foresight, planning, and possibly even communication strategies that extend beyond instinct. Social learning, observed in modern birds, could have amplified over millions of years, creating traditions, innovations, and perhaps even proto-technology. The long evolutionary runway gives these scenarios plausibility, even if tangible evidence remains elusive. Then comes the question of scale. If intelligent dinosaurs existed, how far could their influence have reached? On a global scale, subtle chemical modifications, selective environmental manipulation, or large-scale engineering of habitats could leave traces detectable today, but only if we interpret them correctly. Carbon isotope ratios of sediment layers, traces of controlled fires, or unusual mineral distributions might be the only whisper left of a civilization that once shaped the planet. They wouldn't resemble anything we recognize as human civilization, but the fingerprints could still be there, encoded in the chemistry of Earth itself. And as we imagine all this, the unsettling truth sinks in. The absence of direct artifacts does not prove absence of intelligence. The deeper we dig into Earth's history, the more we realize that the planet actively erases the past. Erosion, tectonics, oceanic recycling, volcanic activity, all conspire to obliterate physical traces. Cities crumble, bones dissolve, metals corrode, and even the hardest stone succumbs over millions of years. The Earth is not a museum. It is a relentless recycler. The likelihood of finding a skyscraper fossilized from the age of dinosaurs is astronomically low, but anomalies, chemical traces, and patterns remain, quietly preserved, waiting for the right mind to notice. So, if dinosaurs could have developed intelligence, and if they could have engineered their world in ways subtle enough to survive geological erasure, what might that look like today? Perhaps scattered, unrecognizable anomalies in rock and ice. Perhaps the traces are already around us, misinterpreted or dismissed as natural oddities. And if they vanished before leaving obvious monuments, what lessons could we learn from their fate? Perhaps intelligence, no matter how dominant, is fragile in the face of planetary scale change. Perhaps survival requires not just power, but humility, foresight, and the ability to navigate the hidden pitfalls of a world far older and more complex than we can imagine. The more we study the fossil record, the more questions emerge. Dinosaurs were not just giant reptiles. They were diverse, adaptable, and in some cases, astonishingly sophisticated. The potential for intelligence in such a lineage challenges our assumptions, forcing us to confront the possibility that Earth's history may hold stories we are only beginning to glimpse. A civilization could have existed, thrived, and vanished without leaving a single stone behind. All that would remain are whispers in chemistry, anomalies in isotopes, and subtle signatures buried beneath millions of years of sediment. And those whispers, if interpreted correctly, could rewrite everything we think we know about who came before us. If dinosaurs or any other ancient intelligence ever built civilizations, the first question that comes to mind is simple. Why don't we see any evidence? The answer, disturbingly, is that Earth itself is the ultimate archivist and destroyer at the same time. It preserves only what it chooses, and it erases everything else with relentless efficiency. Mountains rise and crumble, rivers carve and shift, glaciers grind continents into dust. Tectonic plates drift slowly across the surface, subducting coastlines, folding continents, and burying evidence under thousands of meters of rock. Entire oceans are created and destroyed, carrying with them the memory of what once existed on their floors. By the time humans appeared, millions of years of history had already been obliterated, and what remained was scattered and faint, often disguised as natural formations or random chemical anomalies. Think of the Egyptian pyramids, structures designed to endure for eternity. They've existed for barely 4,000 years, and already they show significant erosion from wind, rain, and seasonal temperature changes. Imagine a structure left exposed for millions of years, subjected to the constant grinding of weathering, earthquakes, and volcanic activity. It would vanish entirely, leaving only subtle hints in the surrounding rock or sediment. And even if a civilization built underground, with chambers carved into stone or packed with protective material, tectonics would eventually crush, shift, or flood those spaces. The Earth is not a passive surface. It is a dynamic, ever-recycling machine that systematically erases almost every trace of the past. Erosion itself is a surprisingly powerful force over geological timescales. Mountains that once towered higher than the Himalayas have been worn down to gentle hills. Rivers relentlessly cut valleys, transporting sediment and gradually filling basins. Desert sands shift with wind and time, covering any remains that might have survived surface exposure. Even in the most stable environments, chemical weathering decomposes minerals slowly but inexorably, breaking down metals, ceramics, and even stone until they lose all recognizable structure. And this is just the slow, inevitable process of time. Add in episodic events like volcanic eruptions, earthquakes, tsunamis, and storms, and any fragile remnants of a civilization are virtually guaranteed to be erased. Oceanic recycling is another ruthless mechanism. The crust of the ocean floor is constantly being generated at mid-ocean ridges and destroyed at subduction zones. The oldest oceanic crust on Earth is only about 200 million years old, because the planet continually creates new crust while the old disappears into the mantle. Any ancient coastal city, dock, or settlement would have been systematically swallowed by the shifting oceans. Even if a civilization somehow thrived in inland areas, rivers and lakes would transport sediments, bury structures, or flood valleys repeatedly over millions of years. The Earth ensures that few, if any, human-scale constructions can survive beyond a geological blink. Glaciers compound the problem, scraping the land clean as they advance and retreat. In ice ages, entire regions of North America and Europe were scoured by kilometers-thick ice sheets. The movement of this ice pulverizes rock, grinds forests into powder, and drags everything across vast distances. When the glaciers melt, they leave behind little more than polished rock and erratic boulders. Even structures buried beneath ice are compressed, fractured, and altered, leaving only distorted shapes that may bear no resemblance to the original creation. The repeated cycles of glaciation erase any continuity of history, leaving researchers with fragmented clues that are difficult to interpret. Volcanic activity adds another layer of destruction. Lava flows can bury entire landscapes, entombing cities under thousands of feet of molten rock that eventually hardens into unrecognizable stone. Hot gases and acidic ash chemically alter buried materials, breaking down metals and organics, sometimes leaving only fossilized impressions of what once stood. Major eruptions can also reshape entire continents, redirect rivers, and annihilate forests, wiping out not just life but any traces of civilization in the process. Even the so-called durable technologies of an intelligent species would be vulnerable to this relentless geological violence. But Earth doesn't just rely on natural forces to erase history, it operates like a recycling machine. Organic materials decay rapidly, leaving only the most durable substances behind. Wood rots, fibers disintegrate, and even bones eventually succumb to pressure, chemical reactions, and microbial activity. Metals corrode unless protected in specific environments, and ceramics, though resilient, are still susceptible to fracturing and chemical alteration. Plastics, if they existed millions of years ago, would degrade into molecular fragments, unrecognizable and indistinguishable from natural compounds. Electronic components and machinery would corrode into unrecognizable shapes long before sediment turned to stone. The fossilization process favors only the hardiest and most fortunate objects, leaving an incomplete, highly selective record of the past. Even large-scale structures, like massive stone complexes or underground facilities, face almost insurmountable odds. Earthquakes fracture foundations, rivers undercut walls, and sediment slowly buries anything left exposed. When tectonic plates collide, buried ruins are folded, crushed, and reincorporated into new rock formations, leaving no clear signature of intelligence. In short, the planet is actively hostile to the preservation of civilization. In this context, it is almost miraculous that we have discovered any traces at all, such as Oklo in Gabon, where nuclear signatures stubbornly persist despite billions of years of geological chaos. Climate fluctuations also play a role in erasure. Rising and falling sea levels flood and expose lands repeatedly, eroding and redepositing sediments across vast areas. Temperature swings cause rocks and artificial structures to expand and contract, creating cracks, fractures, and eventual collapse. Wind and rain accelerate chemical breakdown. Even the slow accumulation of atmospheric changes, like the presence of oxygen, can alter materials, oxidizing metals and chemically transforming stones. Every environment on Earth is in flux, ensuring that nothing remains untouched for long. Biological activity compounds the problem further. Roots penetrate foundations, breaking apart stone and concrete. Microbes decompose organic matter and corrode metals. Animal activity, from burrowing mammals to the tiniest insects, can redistribute materials and accelerate decay. Forests grow over ruins, trapping them under layers of soil and leaf litter. Over millions of years, this biological recycling can completely erase traces of a civilization, leaving only subtle chemical or isotopic signatures behind. Even in the oceans, the evidence would vanish rapidly. Corrosion, bioactivity, sedimentation, and currents combine to obscure any sunken settlements. Underwater structures may survive longer than those on land due to reduced oxygen levels in some environments. But even the deep ocean is not immune to geological recycling. Subduction zones and volcanic activity eventually consume seafloors, erasing the most ancient footprints of intelligence. The Mariana Trench and other deep-sea environments may preserve anomalies, but they are hidden beneath miles of mud and sediment, beyond easy reach. And yet some traces do persist. Dense, chemically resilient materials, certain ceramics, diamond, metallic glasses, and crystalline minerals can survive for tens of millions, even hundreds of millions of years, under the right conditions. These materials might revert tool marks, geometric structures, or chemical signatures long after the civilization that produced them has vanished. Even here, though, detection is not simple. Such artifacts may be buried deep beneath rock layers, frozen in ice, or concealed in remote deserts, waiting for an observer with both the tools and the imagination to recognize them. This relentless erasure explains why the fossil record and archaeological evidence give the impression of an empty prehistory. Earth does not maintain a museum of civilizations, it actively erases them. If advanced species rose and fell millions of years before humans, their cities, tools, and monuments would be gone, leaving only the faintest fingerprints encoded in chemistry, isotopes or anomalies in sediment and rock. Our very assumptions about what constitutes proof are skewed by our experience with human artifacts. We expect intact structures, preserved tools, or recognizable art. But the deeper truth is that intelligence leaves subtler traces when faced with geological time. Understanding these mechanisms is crucial. It is why anomalies like the Oklo reactors or unusual isotope ratios in ice cores seem so compelling. They are fragments of stories almost completely erased, surviving against the odds in ways that defy natural explanation. If intelligent species existed before us, the majority of their history has been scrubbed clean. What remains are whispers in the rocks, chemical shadows in ice, and anomalies in sediment, tiny pieces of a puzzle we are only beginning to notice. The implications are staggering. Entire civilizations could have risen and vanished without leaving a single recognizable structure behind. Large-scale agriculture, cities, or even industrial processes might have altered the chemistry of the Earth in ways detectable today, but only if we know what to look for. And the more we understand the erasure processes, the tectonics, erosion, climate, and biology, the better we can interpret the faint traces that remain. The past is not gone, it is hidden, waiting for discovery by those willing to read the subtle language of a planet that does not forgive. In this light, the question is no longer whether intelligent life existed before humans, but how we can hope to find it. To do so, we must think like a detective of deep time, interpreting faint anomalies, chemical signatures, and geological oddities as possible evidence. The Earth hides its secrets meticulously, yet it cannot erase everything. Somewhere buried beneath mountains, ice, oceans, and deserts, the fingerprints of civilizations long vanished await recognition, offering tantalizing clues about the extraordinary possibilities of life on our planet and the civilizations that may have come before us. Buried deep within the ice of Greenland and Antarctica lie tiny time capsules, frozen snapshots of Earth's atmosphere stretching back hundreds of thousands of years. These ice cores are more than just danked frozen water. They are archives of carbon, methane, and other gases that reveal the history of the planet's climate, the rise and fall of species, and the subtle fingerprints left by life itself. Scientists drill carefully, extracting long cylinders of ice that contain trapped bubbles of air, each one a microscopic record of what the atmosphere looked like at a precise moment in time. And what they have found is nothing short of extraordinary. The chemical composition of these ice cores sometimes displays spikes in carbon and methane that are impossible to explain by natural processes alone. There are sudden surges in greenhouse gases, appearing tens or even hundreds of thousands of years before humans could have had any industrial impact. In some layers, the carbon isotopes resemble those created by burning fossil fuels. Yet these anomalies predate the advent of civilization by unimaginable spans of time. Methane concentrations fluctuate sharply, rising and falling in patterns that suggest sudden, intensive energy releases on a scale far beyond volcanic activity. These are anomalies that cannot be ignored, anomalies that hint at the possibility of industrial activity long before humans walked the Earth. Even more puzzling are the rare metals and chemical elements discovered in these ancient ice cores. Platinum, nickel, and other trace elements appear in concentrations that do not match natural deposition patterns. Geologists argue about meteor impacts, volcanic eruptions, or chemical leaching, but the distributions remain inconsistent with purely natural explanations. Some layers even contain unusual isotopic ratios that are strikingly similar to what modern industrial processes produce. The idea that Earth may have hosted civilizations capable of altering their environment chemically, long before us, begins to gain an eerie plausibility. The implications of this are profound. Ice cores act like a planetary memory, preserving the faint traces of activity that occurred long before human history. They are meticulous record keepers, capturing shifts in the atmosphere that occur over centuries or millennia. If a civilization existed millions of years ago, even if it left no cities, monuments, or artifacts, it could still have left a chemical signature in the atmosphere. A few decades of industrial activity could leave a detectable spike in carbon, methane, or trace metals, and the longer that activity lasted, the more pronounced its mark would be, encoded within the frozen archives of ice, preserved against the relentless erasure of time. One particularly striking anomaly appears around periods of rapid warming and cooling, when ice cores show sudden surges of greenhouse gases paired with unusual isotopic ratios. Some scientists attribute these to natural causes, like volcanic eruptions, methane clathrate releases, or asteroid impacts. Yet, in multiple cases, the scale, frequency, and composition of the anomalies defy conventional explanation. The surges are not gradual, they are abrupt, concentrated, and intense, suggesting a source of energy and activity unlike anything produced by geological processes alone. These spikes could reflect bursts of industrial activity, atmospheric manipulation, or even unknown forms of technology operated by civilizations lost to time. It is tempting to dismiss these anomalies as coincidences or misinterpretations, but when patterns recur across multiple ice cores and in distant locations, a more unsettling possibility emerges. If different regions, separated by thousands of kilometers, display the same sudden chemical patterns, it implies a global phenomenon. A local volcanic eruption or meteor impact cannot account for such widespread anomalies. Something or someone was shaping the planet on a massive scale. The evidence is subtle, almost whispering, but the consistency is there. These chemical fingerprints, trapped in ice for hundreds of thousands of years, suggest that Earth's history may contain chapters we have never read. Even more intriguing are the links between these anomalies and mass extinctions. In some cases, chemical spikes in carbon and methane precede or coincide with the disappearance of species. Could this indicate that ancient civilizations inadvertently triggered environmental collapse? If industrial-scale activity existed long before humans, it may have contributed to planetary-scale disruptions, echoing the patterns of extinction we discussed earlier. The ice cores, silent and frozen, act as witnesses to these events, preserving the story in ways that rocks, fossils, and sediments often cannot. The anomalies extend beyond carbon and methane. In some ice layers, scientists have detected rare traces of synthetic compounds, substances that do not occur naturally and should not exist in the prehistoric atmosphere. While some of these measurements are controversial, the fact that they appear at all in ice tens of thousands or even millions of years old is compelling. These compounds hint at technologies that predate our own understanding of chemistry and manufacturing. They are the kind of evidence that could suggest intelligent activity on a scale we can barely imagine. Consider the timing of these anomalies. They often occur during periods when the Earth's climate was stable enough to support complex life, yet fragile enough to be dramatically affected by environmental stress. The spikes in carbon and methane correspond to eras when life was abundant, when forests, oceans, and land masses teemed with creatures of incredible diversity. If intelligent species existed at these times, they would have had both the capacity and the opportunity to alter the atmosphere, intentionally or unintentionally, leaving behind the chemical footprints we now detect. The mystery deepens when we compare these ice core anomalies with other geochemical evidence. Certain sediment layers, millions of years old, contain unusually high concentrations of metals like nickel, copper, and lead elements that are critical in industrial processes. Together with the chemical spikes in ice, they suggest activity on a scale that cannot be explained by natural phenomena alone. The pattern hints at civilizations capable of large-scale environmental manipulation, long before humans learned to burn coal or refine metals. Even the most skeptical scientists admit that these anomalies demand explanation. While natural causes are plausible in some cases, the combination of timing, chemical composition, and global distribution makes purely geological explanations increasingly tenuous. It is as if the planet itself is leaving us clues, tiny but persistent, urging us to consider that intelligent life may have existed long before humans claimed dominion over the Earth. The ice cores, like letters from an ancient era, whisper a story of civilizations rising and falling, of energy unleashed and forgotten, of traces left behind in the most unexpected places. And yet, the ice preserves only a fraction of what once existed. While chemical anomalies offer tantalizing hints, they cannot tell the full story. We cannot see the cities, the tools, or the machines that might have existed. We can only interpret the subtle changes in the atmosphere, the unusual isotopes, and the metal deposits. They are fragments, scattered and cryptic, requiring both imagination and meticulous scientific analysis to decode. But if read carefully, they suggest a narrative that is both astonishing and unsettling. The possibility that Earth has hosted intelligent life long before humanity, and that our understanding of history is just the tip of the iceberg, literally frozen in time. The significance of these ice core anomalies cannot be overstated. They challenge the assumption that human civilization is the first capable of altering the planet on a global scale. They force us to confront the possibility that intelligence may have emerged, flourished and disappeared multiple times in Earth's history, and they remind us that, even when physical structures vanish, when cities crumble and fossils dissolve, subtle chemical signatures can endure, quietly telling the story of civilizations that have been erased by the relentless forces of geology and time. If these frozen archives hold such secrets, what else might be hidden elsewhere? Rocks, sediments, and deep ocean deposits may contain equally compelling evidence. The planet's memory is vast, and while much has been erased, fragments remain, waiting to be discovered. The ice cores are merely one piece of a larger puzzle, a frozen testimony to possibilities that stretch the imagination, forcing us to rethink what we know about the history of life and intelligence on Earth. And as we continue to probe these anomalies, one inescapable conclusion emerges. Earth may have hosted civilizations before humans, civilizations that left only whispers behind, preserved in the most unlikely and enduring archives, the ice itself. The story of nuclear energy on Earth does not begin with the 20th century, with scientists like Fermi or Curie. It stretches far deeper, buried in the rocks themselves, in formations so old that human history seems like a blink in comparison. While ice cores hint at chemical anomalies and possible industrial activity, uranium deposits tell a more provocative tale. In Gabon, Africa, the Oklo natural nuclear reactors provide the clearest evidence that nuclear fission is not strictly a modern phenomenon. But the story does not end there. Across the world, geologists and physicists have identified other uranium-rich formations containing isotopic ratios that are difficult to explain through natural processes alone. These deposits suggest that the planet itself may have hosted energy releases on a scale that rivals modern nuclear technology, long before humans existed. At Oklo, we see uranium-245 depleted in ways that indicate long-term chain reactions. But when researchers examined surrounding formations, they noticed traces of isotopes like plutonium-239 and neodymium-143, the very byproducts of sustained fission. These isotopes are not stable in the long term, yet they appear in ratios consistent with controlled reactions, suggesting that these were not chaotic natural events. In modern reactors, achieving such precision requires careful moderation, the right concentration of fuel, and control over neutron flux. For a reaction to occur naturally and yet mimic these conditions so closely stretches the limits of coincidence. Some scientists chalk it up to geology, arguing that groundwater, uranium concentration, and mineral placement aligned perfectly. But the more one examines the evidence, the less perfect coincidence seems like a satisfactory explanation. Even stranger are the enriched uranium deposits found in other ancient formations around the globe. In some regions, researchers have measured unusual U-235 to U-238 ratios that do not conform to standard decay rates or expected geological distributions. These deposits suggest either repeated natural concentration mechanisms or, more provocatively, the possibility of intelligent manipulation. If an advanced civilization existed billions of years ago, it could have concentrated uranium and harnessed it for energy, leaving behind isotopic fingerprints buried deep in stone. The very idea challenges our understanding of history, forcing us to consider intelligence arising long before humans, and yet leaving behind nothing recognizable but chemical evidence. The implications of this are staggering. Enriched uranium requires precision, control, and knowledge. Knowledge we consider uniquely human. To see the same isotopic patterns in formations that predate our species by millions or even billions of years is to confront a profound question: could intelligence in some form have existed on Earth long before humans? The Oklo reactors are unique in their preservation, but they may represent just one surviving fragment of a much larger and older network of activity. What if civilizations arose, learned to manipulate energy, and then vanished, their works erased by time, leaving only these subtle traces in the bedrock? Plutonium, a synthetic element in our timeline, is found as a byproduct in these formations. In modern reactors, plutonium is created when uranium-238 absorbs neutrons, a process that requires controlled fission. That this occurs naturally is remarkable in itself, but the isotopic ratios at Oklo and nearby formations suggest the reactions ran long enough, and with sufficient moderation to mimic engineered nuclear processes. The waste products were confined within layers of rock, preserved for billions of years. Modern humans struggle with containment. Ancient processes seem to have achieved it effortlessly. Could this be purely a fluke of geology, or does it hint at an intelligence that understood energy, containment, and reaction far before us? These uranium anomalies align intriguingly with other mysterious geological and chemical evidence. Carbon spikes in ice cores, metals out of place in sedimentary layers, and unexplained chemical compounds all point to the same possibility: that Earth has experienced industrial-scale manipulation in the distant past. It is as if these anomalies form a pattern, a trail of breadcrumbs left in the geological record. And yet, the pattern is subtle, easily dismissed, requiring sophisticated analysis and a willingness to challenge conventional assumptions about Earth's history. When we examine the global distribution of these uranium and plutonium anomalies, an unsettling narrative begins to emerge. Multiple continents display concentrations of isotopes that suggest sustained energy release, controlled reactions, and environmental management. The scale is enormous. It is not limited to a single geological accident or rare mineral configuration. This points to a phenomenon or a civilization that operated across vast regions, with an understanding of nuclear energy that would be considered advanced even by modern standards. It raises the question: if such knowledge existed, why did it disappear, and how could it vanish without leaving recognizable cities, tools, or machinery? The answer may lie in the scale of geological time. Natural forces act slowly but inexorably, erasing everything fragile. Buildings crumble, metals corrode, and cities vanish beneath sediment and stone. Even underground structures, protected from the elements, eventually succumb to pressure, earthquakes, and volcanic activity. Over millions of years, the most advanced civilizations could be reduced to chemical traces in the rocks, preserved only under exceptional circumstances, like those found at Oklo. The deeper we dig into Earth's crust, the more we realize that absence of evidence is not evidence of absence, it is evidence of erasure. The Oklo reactors also offer a chilling cautionary tale. Civilizations that harnessed energy may have unintentionally altered their environment on a planetary scale. Consider the chemical fallout, isotopic shifts, heat released into local environments, and subtle changes in surrounding minerals. Even today, our nuclear and industrial activity leaves detectable traces. Extrapolate backward billions of years, and it is plausible that ancient civilizations could have inadvertently contributed to environmental disruptions, triggering extinctions or ecological shifts. The uranium anomalies are not just relics, they are warnings, frozen in stone, whispering across eons about the delicate balance between intelligence and planetary systems. Moreover, the precision of these natural or engineered reactors suggests a sophistication that surpasses random chance, achieving sustained fission without catastrophic meltdown, maintaining waste containment, and controlling reactions over thousands of years all point to either incredible geological luck or deliberate design. If it is the latter, it implies that intelligence capable of manipulating atomic energy existed long before humans, with the potential for both incredible achievement and catastrophic failure. The implications for our understanding of history, science, and civilization are profound. It is not just the Oklo site that compels this conclusion. Other uranium-rich formations around the world show similar anomalies, suggesting that these are not isolated events. The patterns, the ratios, and the containment all point toward repeated processes. Whether these were natural phenomena of extraordinary luck or the remnants of civilizations lost to time, the evidence challenges our assumptions about what is possible on Earth. It demands that we ask questions that feel almost heretical. Could intelligent life have existed on this planet long before humans? Could it have mastered energy, industry, and technology in ways that we cannot yet comprehend? The more we study these ancient uranium anomalies, the more the pieces of a broader, unsettling puzzle begin to fit together. Ice cores, sedimentary metals, carbon spikes, and natural reactors all suggest the presence of intelligent activity that predates humanity, and yet the planet has erased nearly all traces, leaving only subtle chemical and isotopic whispers in its wake. These anomalies are fragments of a forgotten history, tantalizing clues that the Earth may have hosted civilizations long before our species appeared. In contemplating these traces, we are forced to rethink everything we believe about the history of life on Earth. Human civilization may not be the first to harness energy, manipulate the environment, or rise to dominance. There may have been others, their knowledge lost, their achievements buried beneath mountains, oceans, and ice, their existence remembered only in the most subtle fingerprints of the planet itself. Oklo and similar uranium anomalies are not just geological curiosities, they are relics of a possible past, urging us to imagine civilizations older than humanity, advanced beyond our comprehension, and erased almost entirely by the relentless forces of time. The deeper you dig into Earth's history, the more anomalies appear, objects that seem impossible for their age, artifacts that defy the natural processes that dominate our planet. These out-of-place artifacts are the kind of evidence that, if genuine, could rewrite everything we think we know about civilizations long before humans. One of the most famous examples is the Wolf's Egg iron, discovered in Austria embedded in a 20-million-year-old rock. This small iron cube is perfectly formed, geometric and unmistakably manufactured, or so it seems. It's small enough to be dismissed as curiosity, but its presence in a rock layer predating humans by tens of millions of years is profoundly unsettling. How did it get there? Was it dropped by chance? Or does it hint at a civilization whose memory has been erased entirely? The Wolf's Egg iron is not an isolated incident. Throughout the world, countless artifacts have been discovered in geological contexts that should make their existence impossible. Ancient gold chains found in coal seams, metal nails embedded in sandstone, and crystalline structures shaped with geometric precision all defy conventional timelines. Skeptics often attribute these finds to hoaxes or misinterpretation, and some undoubtedly are. Yet, a few remain stubbornly resistant to debunking, their authenticity verified through chemical analysis and rigorous testing. What's striking is not merely that these objects exist, but that they appear in contexts where human activity is impossible, embedded in layers of Earth that predate our species by millions of years. Consider the context of coal. Coal forms from compressed plant matter over tens of millions of years. Any object found inside a coal seam is by definition older than the coal itself. That means a gold chain, perfectly formed, appearing in coal deposits that formed long before humans existed, cannot be explained by ordinary archaeology. The first reaction is disbelief. Our brains instinctively reject the notion. But when artifacts appear repeatedly, across continents and time periods, a pattern begins to emerge, one that challenges the linear view of history we take for granted. Some researchers have catalogued these anomalies systematically, noting their age, composition, and geological context. The common thread is that they appear where they should not exist, their design and material composition suggesting intelligence, yet without any accompanying evidence of civilization. There are no cities, no inscriptions, no accompanying tools, just the objects themselves, surviving against the odds in rock and sediment. It is as if civilizations once existed and then vanished, leaving only these silent tokens behind, puzzles for future generations to discover. The mystery deepens when we examine the complexity of these artifacts. The Wolf's Egg iron, for example, is not a simple lump of metal. Its shape is nearly perfect, with straight edges and precise angles, suggesting careful crafting rather than random natural processes. Gold chains embedded in coal often show uniform links too precise to have formed through natural crystal growth. Nails found in stone appear forged, their shapes too regular to be explained by mineral inclusions or geological pressure. These objects carry signatures of intentionality, human-like precision, but they belong to an era when humans did not exist. The implications are staggering. Either the objects are natural anomalies of a type we do not yet understand, or they are remnants of civilizations that rose, flourished, and disappeared millions of years before humanity. If the latter is true, it fundamentally challenges our understanding of intelligence and technology on Earth. It forces us to confront the possibility that history is cyclical. Civilizations emerge, develop technology, alter their environment, and vanish, leaving only subtle clues behind. These artifacts could be the fingerprints of that lost intelligence, small but profound evidence that the planet has been home to advanced life before us. Even more perplexing are artifacts found in coal seams and sediment layers alongside extinct species. Fossils of creatures long gone exist in the same strata as objects that appear to be manufactured. Could it be coincidence? Perhaps. But repeated occurrences across different continents make coincidence harder to believe. In some cases, metals found in ancient rock have isotopic ratios that match those produced by smelting or industrial processes rather than natural formation. These are not random anomalies. They suggest an interaction with intelligent activity, the manipulation of materials for purposes beyond survival or natural occurrence. The challenge in studying these artifacts is not just verifying authenticity, but interpreting them. Without context, it is difficult to know their function or significance. A chain link tells us almost nothing about the culture that produced it. A metal cube cannot reveal the values, governance, or knowledge of the civilization that created it. What survives is only a trace, a whisper across millions of years, demanding inference and imagination. Yet even this whisper is enough to challenge our conventional narratives of history. Some archaeologists and geologists have attempted to explain away these anomalies through natural processes. Iron cubes, for example, could form through mineralization under specific pressures and chemical conditions. Gold chains could be misidentified clusters of natural metals. Nails might be naturally formed iron concretions. But these explanations are often unsatisfying. Many of these objects exhibit precision and consistency that are extraordinarily difficult to reproduce through natural means. In some cases, the metallurgy and design defy known geochemical processes, suggesting that intentional fabrication is a more plausible explanation. The pattern of these anomalies is also global. Similar artifacts appear on different continents, in sedimentary layers from different geological periods. This suggests that if ancient civilizations existed, they were not limited to one location. Intelligence may have emerged multiple times, or spread widely across the globe, only to vanish without leaving cities, monuments, or enduring technologies. The very survival of these small objects amidst eons of geological upheaval is remarkable. It is almost as if the planet has been carefully selecting what traces to preserve, teasing us with fragments of a forgotten story. What is especially fascinating is the intersection of these artifacts with other anomalies we have discussed. Chemical spikes in ice cores, enriched uranium deposits, unusual isotopic distributions, and geological oddities. Viewed in isolation, each of these phenomena might seem unremarkable, but when taken together, they test a planet that has experienced repeated periods of advanced activity, technology, energy manipulation, environmental alteration, followed by disappearance and erasure. The artifacts are the most tangible, visceral evidence of these cycles, small remnants of civilizations that rose and fell in silence. Even considering human psychology, these discoveries are difficult to accept. Our brains are wired to interpret history linearly. Humans emerge, civilizations develop, technology progresses. Accepting that intelligent species may have existed before us challenges fundamental assumptions about time, progress, and uniqueness. Yet the evidence cannot be dismissed entirely. The artifacts remain stubbornly present, concrete, and undeniable, demanding that we ask uncomfortable questions about the history of life and intelligence on Earth. The out-of-place artifacts also raise questions about the limits of detection. If civilizations existed millions of years ago, how much of their history can possibly survive? Buildings, machines, tools, almost nothing. Time, tectonics, erosion, ice, and biological activity erase all but the most durable traces. Yet even a single iron cube, a gold chain, or a small nail can become a beacon across eons, a message in a bottle from a world long gone. These anomalies challenge us to reconsider what constitutes proof, forcing us to look beyond the obvious and seek subtle patterns hidden in the planet's geology. As we examine these objects, one principle becomes clear: Earth is a master of disguise. It erases, buries, and recycles, leaving only cryptic signals for those willing to interpret them. The wolf's egg iron, gold chains, nails, and other anomalies are fragments of stories that existed in full only long ago, now reduced to whispers preserved against impossible odds. And yet, those whispers may be enough. They are the threads that, when pulled carefully, could unravel a history far stranger and more complex than anyone has imagined, a history in which intelligence, technology, and civilization are far older and more enigmatic than humanity's short tenure on this planet. Around 540 million years ago, Earth experienced one of the most astonishing events in the history of life, the Cambrian explosion. In what seems like a geological heartbeat, a vast array of complex organisms appeared seemingly out of nowhere. Creatures with hard shells, compound eyes, intricate body plans, and specialized appendages suddenly filled the oceans. The diversity and sophistication of life forms emerging during this period challenged conventional evolutionary explanations, prompting some scientists to ask, could something more than natural selection have influenced this extraordinary burst of complexity? Before the Cambrian, life on Earth was mostly simple, soft-bodied, microscopic, and relatively uniform. Then, in a remarkably short span of around 20 to 25 million years, complex organisms with sophisticated anatomies and behaviors proliferated. Trilobites scuttled across the seafloor with compound eyes and articulated limbs. Anomalocaridids hunted with precision, suggesting predatory strategies and sensory awareness far beyond what we expect from organisms of that era. Sponges, brachiopods, early mollusks, all appeared suddenly, seemingly without the gradual evolutionary precursors that Darwinian theory would predict. It is as though the biosphere received an infusion of ingenuity, a spark that accelerated life toward complexity at an unprecedented pace. The sudden emergence of these organisms poses a profound question. How could evolution, typically considered a slow and incremental process, produce such a vast variety of complex life in such a compressed time frame? Some paleontologists point to changes in oxygen levels, the breakup of supercontinents, or ecological pressures as catalysts. Yet none fully account for the speed, scale, and sophistication of the Cambrian diversification. The chemical and environmental conditions may have created an opportunity, but opportunity alone does not explain the sudden engineering of sensory organs, limbs, and predatory adaptations across multiple phyla simultaneously. Some researchers have speculated that external factors could have nudged evolution in certain directions. Could an advanced intelligence, long lost to time, have influenced genetic pathways or ecosystems to accelerate the development of complex life? If intelligent civilizations existed on Earth before humans, they may have left subtle marks on the biosphere, manipulating chemical environments, introducing selective pressures, or even experimenting with early forms of bioengineering. The Cambrian explosion could be interpreted as a planetary-scale laboratory, where environmental conditions were deliberately or unintentionally altered to promote rapid diversification. The fossil record adds further intrigue. Many Cambrian creatures display features that are highly specialized, optimized for survival and predation. Eyes capable of detecting polarized light, appendages adapted for precise movement, and armored exoskeletons suggest evolutionary leaps that are difficult to attribute purely to random mutation and selection over such a short time. Could natural processes alone account for the repeated emergence of such complex adaptations in multiple lineages? Or is there something more at play? Some scientists cautiously entertain the notion that an external influence, a catalyst beyond the usual evolutionary mechanisms, may have shaped the trajectory of life during this pivotal period. Chemical evidence supports the idea that Earth's environment underwent dramatic changes during the Cambrian. Oxygen levels rose sharply, enabling larger body sizes and more active metabolisms. Mineral compositions shifted, creating habitats suitable for hard-shelled organisms. Nutrient cycles changed, opening ecological niches and promoting competition. These conditions, while necessary, may not have been sufficient to explain the precision and rapidity of life's diversification. It is the combination of opportunity and precise orchestration that fuels speculation. Life didn't merely evolve, it exploded, as though guided by unseen hands shaping the direction of complexity. The Cambrian explosion also coincides with geological anomalies. Layers of rock from this period often contain unusual isotopic ratios, metals in concentrations that are difficult to explain, and other chemical signatures that hint at large-scale environmental interventions. Could these anomalies, be the fossilized echoes of activities conducted by civilizations now long vanished. If life was influenced, even indirectly, by technological or environmental manipulation, then the Cambrian explosion may represent one of the earliest fingerprints of intelligent interference in Earth's biosphere. Consider the implications. If advanced species existed before humans, and if they had the knowledge or capability to influence evolution, then the sudden emergence of complex life forms in the Cambrian may not be coincidental. It may reflect a deliberate or accidental acceleration of biological processes on a planetary scale. The sophistication of these early creatures, coupled with the chemical and geological anomalies of the period, suggests a world in which intelligence, energy, and environmental manipulation intersected long before humans ever appeared. The notion is not purely speculative. Modern science is beginning to recognize that life can be influenced by factors far beyond immediate selection pressures. Epigenetic mechanisms, gene flow, and horizontal gene transfer can accelerate the development of complex traits. Environmental catalysts, such as radiation, chemical concentrations, or temperature shifts, can dramatically alter the course of evolution. If such mechanisms were amplified by an intelligent presence, the rapid diversification of the Cambrian becomes less mysterious and far more provocative. Some proponents of this theory point to the consistency of the explosion across the globe. Cambrian fossils appear on multiple continents, showing simultaneous bursts of complexity in disparate ecosystems. This suggests that the underlying cause was not localized but global, affecting oceans, atmosphere, and ecological networks simultaneously. If intelligence played a role, its reach must have been planetary, capable of influencing multiple environments in synchrony. The idea is difficult to accept, yet the fossil record, the chemical anomalies, and the sheer speed of diversification leave questions that remain unanswered by conventional evolutionary theory alone. Even more tantalizing is the possibility that this early manipulation of life left traces beyond fossils and rocks. Some researchers speculate that isotopic anomalies in sedimentary layers, unusual concentrations of metals, or patterns of mineral deposition could all reflect processes associated with environmental engineering. These signals, subtle yet persistent, may encode the remnants of activity by civilizations that existed millions of years before humans. It is a record not of architecture, but of influence, an indirect signature of intelligence exerted over life itself. The Cambrian explosion forces us to reconsider our assumptions about history. It challenges the linear narrative in which humans represent the pinnacle of intelligence, suggesting instead that Earth may have been host to multiple epochs of advanced activity, each leaving behind only faint whispers. If the sudden emergence of complex life was influenced by intelligence, the Cambrian may be one of the earliest and most enduring examples of planetary-scale engineering. The fossil record, chemical anomalies, and geological evidence together paint a picture of a world that has been shaped by forces both natural and possibly intelligent. A planet where intelligence may have arisen, flourished, and vanished long before we ever walked its surface. In contemplating the Cambrian explosion, one must balance skepticism with curiosity. It is a period defined by extraordinary biological creativity, rapid evolutionary leaps, and the sudden appearance of life forms that defy expectations. While natural explanations remain compelling, they are incomplete. The anomalies in fossils, chemical evidence, and geological context hint at influences that we do not yet fully understand, possibly the fingerprints of intelligence operating on a planetary scale. If true, the Cambrian explosion is not just a chapter in Earth's biological history. It is a tantalizing, almost terrifying glimpse into a history of intelligence, experimentation, and environmental manipulation that predates humanity by hundreds of millions of years. And yet, even with all this evidence, the story remains incomplete. The Cambrian explosion leaves us with more questions than answers. Who or what could have orchestrated such a dramatic acceleration of life? How did these early influences shape the trajectory of Earth's biosphere for millions of years afterward? And most chillingly, if intelligence can rise, manipulate its environment, and vanish without leaving recognizable structures, what does that mean for our own civilization's fate, millions of years from now? The Cambrian explosion is a warning and a puzzle, a period of extraordinary creativity in the natural world, and possibly the first visible fingerprint of intelligence reaching out across the deep history of our planet. For billions of years, Mars was not the desolate, rust-colored desert we see today. Geological evidence suggests that ancient Mars had vast oceans, rivers, and lakes, a stable atmosphere, and a climate capable of supporting life. Satellite imagery and rover explorations have revealed dried-up riverbeds, sedimentary layers, and mineral deposits that form only in the presence of water. The planet was, for a time, remarkably Earth-like, a world that could have nurtured complex life, perhaps even intelligent. The question arises, if Mars was once habitable, why does it now lie barren and lifeless? And could it have once hosted civilizations, now lost to the ravages of time and planetary catastrophe? Ancient Mars offers tantalizing hints that something extraordinary may have occurred. Evidence of standing water, deltas, and lake beds indicates that billions of years ago, the planet had a hydrological cycle capable of sustaining life over extended periods. Mineralogical studies have found clays, sulfates, and carbonate deposits, all of which form in liquid water. Certain regions, such as the northern lowlands, appear to have hosted vast oceans stretching for thousands of kilometers. These conditions, combined with a thicker atmosphere and milder temperatures, suggest that Mars could have supported life far more complex than microbial colonies, potentially even intelligent species capable of manipulating their environment. Rovers and orbiters have revealed additional anomalies, polygonal surface features, unusual geometric patterns, and structures resembling channels, grids, and terraces have been observed in multiple regions. While many of these formations can be explained by natural geological processes, some scientists argue that their regularity, alignment, and apparent symmetry hint at deliberate design. Could these be the remnants of Martian settlements, agricultural systems, or energy harvesting structures? The evidence is fragmentary, but it is consistent with the idea that Mars was once capable of supporting advanced life that could leave enduring traces on its surface. The possibility of Martian civilizations is further supported by meteorites from the planet found on Earth. The most famous of these, ALH 8401, contains microscopic structures and mineral compositions that some researchers argue could be fossilized remnants of microbial life. While controversial, these findings open the door to the idea that life on Mars may have evolved independently, potentially developing complexity or intelligence over millions of years. If microbial life could survive and evolve on Mars, why not more complex forms, especially given billions of years of habitable conditions? One of the most compelling questions is how Mars lost its habitability so completely. The planet's magnetic field, which protects atmospheres from solar wind, collapsed billions of years ago, leading to rapid atmospheric thinning. Water evaporated, oceans disappeared, and surface conditions became hostile to life as we know it. If civilizations had existed, their worlds would have been destroyed in a planetary-scale catastrophe. Cities, technology, and infrastructure, even if once monumental, would have been buried beneath sand, eroded, or vaporized. Mars is, in many ways, the ultimate tomb, a planet that preserves the faintest hints of what once was, yet hides most evidence beneath millions of years of decay. Some researchers suggest that the remnants of Martian civilizations could still be detectable if we know where and how to look. Subsurface ice, sedimentary deposits, and deep rock formations might conceal structures, energy systems, or even fossils. Geophysical scans reveal anomalies beneath the surface, dense, uniform materials that could indicate artificial construction. The presence of unusual chemical compounds in Martian soil, including phosphates and organics, hints at processes that might not be entirely natural. If true, these findings suggest that Mars may hold secrets akin to those we search for on Earth. The silent traces of civilizations, erased by time, preserved only as faint chemical and geological signatures. The possibility of Martian intelligence also raises profound questions about the nature of life in the universe. If two planets in the same solar system, Earth and Mars, could host life capable of complex organization, the probability of intelligent life elsewhere increases dramatically. It suggests that intelligence is not a fluke of Earth's evolution, but a potential outcome in planets with suitable conditions. Yet the silence we encounter, the absence of visible cities, technology, or clear artifacts, forces us to confront the fragility of civilizations. Both Mars and Earth illustrate a sobering principle. Even the most advanced species can vanish without leaving easily detectable traces, erased by planetary processes and the relentless passage of time. The implications extend beyond Mars itself. If intelligence can arise, thrive, and disappear on multiple planets within a single solar system, It underscores the cyclical nature of life and civilization. The rise and fall of civilizations may be a universal pattern, constrained not by morality, ingenuity, or resilience, but by the fragile balance between biology, technology, and environmental stability. Mars provides a stark example, a once habitable planet that lost its atmosphere, oceans, and life-supporting conditions, leaving only geological and chemical remnants as testimony to its past. It is both a warning and a mirror for Earth, a cautionary tale of planetary fragility. The search for Martian artifacts is ongoing. Orbiters equipped with high-resolution cameras map the surface, seeking anomalies that may indicate artificial construction. Rovers drill into sedimentary layers, analyzing chemical compositions for signatures of life or technology. Future missions aim to penetrate the subsurface ice, scanning for hidden structures or traces of ancient activity. Even now, scientists debate whether certain craters, mazes, and polygonal formations are natural or engineered. Every anomaly sparks controversy, yet the pattern is undeniable. Mars holds clues that, if interpreted carefully, could reveal the existence of life forms far more complex than simple microbes, perhaps even intelligent species that left subtle but detectable traces. If civilizations did exist on Mars, what might they have been like? Unlike Earth, Mars lacks abundant surface water today, but billions of years ago it likely had stable seas, fertile plains, and mild climates conducive to advanced life. Its atmosphere, once thicker and capable of supporting biological processes, could have allowed energy systems, agriculture, and large-scale settlements. The possibility that intelligent species evolved there, harnessed resources, and developed technology raises profound questions. Why are no structures visible? Why is the planet silent? The answer, again, is Mars's atmosphere, hydrological changes, and tectonic events have likely erased nearly every trace, leaving only subtle geological and chemical signatures. Studying Mars also reframes our understanding of Earth. If another planet in the same system could host intelligent life, it reinforces the idea that civilizations may have existed on Earth long before humans. It suggests a solar system rich in life's potential, where planets experience cycles of emergence, advancement, and extinction. The anomalies on Mars mirror the mysteries we find on Earth. Nuclear evidence, chemical spikes, and out-of-place artifacts. Both planets hint at a deeper, more complex history of life and intelligence, a history largely hidden from view, preserved only in subtle signatures awaiting discovery. Ultimately, ancient Mars challenges our assumptions about the fragility and permanence of civilizations. It shows us that intelligence can rise, shape its environment, and vanish entirely, leaving behind only traces that require careful interpretation. Whether life on Mars reached the complexity of advanced technology or remained microbial, the possibility alone forces us to reconsider the rarity of intelligence, the inevitability of extinction, and the transient nature of civilizations in the face of planetary forces. Mars is a frozen testament, a silent witness to what may have been, urging us to look deeper, question more boldly, and consider that the history of life is far more intricate and surprising than we have ever imagined. When we think of Venus today, we envision a hellish landscape, a surface hotter than the oven of a pizza kiln, crushing atmospheric pressure, and clouds of sulfuric acid that blot out the sun. It is a planet inhospitable to life as we know it, seemingly the ultimate example of a world gone wrong. But geological and atmospheric evidence suggests that Venus was not always this way. Billions of years ago, Venus may have resembled Earth more closely than we could imagine. Oceans covering its surface, a stable climate, and temperatures mild enough to support complex life. For a time, it may have been a paradise, a sister world capable of nurturing ecosystems and perhaps even civilizations. Data collected from satellites and landers reveal that Venus has a crust and surface composition surprisingly similar to Earth. Its size, gravity, and proximity to the Sun suggest that it could have retained liquid water for long periods. Some models indicate that oceans may have existed for up to 2 billion years, giving life ample opportunity to emerge, evolve, and possibly develop intelligence. During this extended habitable period, Venus would have had climates suitable for photosynthesis, flowing rivers, and maybe even shallow seas where complex organisms could flourish. Imagine a world lush and vibrant, teeming with life and potential. The collapse of Venus's habitability appears to have been catastrophic. Unlike Earth, Venus lacks a magnetic field to protect its atmosphere from solar wind. Over millions of years, the solar wind stripped away much of the planet's atmosphere, causing water to evaporate, hydrogen to escape, and the surface to heat dramatically. A runaway greenhouse effect ensued, transforming Venus into the furnace we see today. If intelligent life had arisen during its temperate era, its civilization would have faced planetary-scale destruction. Cities, technologies, and infrastructures would have been obliterated, buried beneath acidic clouds and volcanic rock, leaving only the faintest traces of existence. Some scientists have speculated that Venus's dramatic transformation may have erased evidence of life or civilizations entirely, but there are hints that some traces could survive. Radar mapping of the surface reveals unusual geological formations, flat plains, regular ridges, and unusual highland patterns that defy straightforward explanation. While volcanic activity and tectonic movements account for much of Venus's current surface, the regularity and scale of certain features raise the possibility of artificial origin or planetary-scale engineering. Could these formations be the remnants of settlements, energy grids, or water management systems from a lost civilization? The evidence is tantalizing, fragmentary, and frustratingly ambiguous. Further intrigue comes from recent studies of Venus's atmosphere. In 2020, phosphine gas was detected at high altitudes, a molecule that on Earth is associated with biological processes. While its presence is debated and may have non-biological explanations, it raises the possibility that life or remnants of life could persist in the more temperate upper layers of Venus's atmosphere. If life survived anywhere on Venus, intelligent life could have evolved during its ocean's era, leaving biochemical or technological traces now suspended in the clouds or embedded in chemical anomalies. It is a provocative idea, a civilization that lived and perhaps thrived, yet vanished without a single conventional monument surviving the planet's transformation. The story of Venus, like Mars, underscores the fragility of civilizations in the face of planetary forces. Even the most advanced species are vulnerable to climate shifts, atmospheric loss, and catastrophic feedback loops. Venus serves as a warning, a world that may have hosted intelligence, yet whose evidence has been almost entirely erased by environmental collapse. If ancient civilizations existed there, their technologies, cities, and achievements would have been obliterated, leaving only chemical or geological hints that can survive billions of years. And yet, those hints are there, waiting for the right eyes to interpret them. The parallels between Venus and Earth are striking. Both planets had periods of temperate, life-supporting conditions, and both are capable of hosting complex ecosystems. If life or even intelligence could arise on Venus, it strongly suggests that the emergence of intelligent civilizations may be more common than we realize. The critical factor is survival. Venus lost its ability to sustain life on the surface, while Earth for now remains habitable. But the fossilized chemical and geological records on Venus could hold clues that, if studied carefully, may reveal the existence of civilizations that perished long before humans walked the Earth. Venus also challenges our understanding of time and decay. If a civilization once thrived there, its survival window may have lasted hundreds of millions of years. During that time, technology could have developed, environmental manipulation could have occurred, and energy systems might have been deployed. Yet in the blink of geological time, the planet transformed completely, erasing nearly all direct evidence. The only surviving signs may be subtle chemical anomalies, unusual rock formations, or atmospheric signatures, traces that require interpretation, imagination, and advanced technology to detect. Interestingly, the harshness of Venus's current environment may have helped preserve evidence in unexpected ways. Unlike Earth, Venus's surface is almost entirely resurfaced by volcanic activity, meaning that areas shielded from lava flows may contain undisturbed crust from its temperate era. High-resolution radar imaging reveals plateaus and regions that appear anomalously uniform, hinting at geological structures that could be natural, but also could be remnants of intelligent activity. If civilization existed there, the upper layers may retain subtle traces of construction, chemical manipulation, or environmental management that could persist through planetary upheavals. The possibility of a lost civilization on Venus also reframes our search for extraterrestrial intelligence. Traditionally, we look to distant stars and exoplanets, searching for life as we know it. But Venus shows us that a planet within our own solar system could harbor evidence of intelligence that predates humans by hundreds of millions, or even billions of years. It suggests that intelligence is not a singular phenomenon, confined to one species or planet, but may arise wherever conditions allow and vanish just as swiftly if planetary stability falters. Venus is both a mystery and a warning. Life can flourish, innovate and vanish without leaving the obvious monuments we expect, yet its traces may persist in the most subtle form. The more we examine Venus, the more its story echoes the broader mysteries we have encountered on Earth and Mars. Geological anomalies, chemical signatures, and atmospheric curiosities all suggest that planets can host life and intelligence long before humans appear. Venus, now inhospitable, was once a fertile world. If civilizations arose there, they would have faced environmental collapse, much like the potential threats faced by civilizations on Earth and Mars. It is a pattern repeated across the solar system. Life emerges, intelligence develops, technology arises, and yet survival is never guaranteed. Ultimately, Venus reminds us that intelligence is fragile, even on worlds that once seemed perfect. Civilizations can rise, manipulate their environment, and vanish, leaving behind only whispers in stone, ice, or atmosphere. Its history challenges our assumptions about uniqueness, resilience, and permanence. If Venus once harbored life or civilization, then the record of its existence is encoded, not in monuments, but in anomalies, chemical, geological, and atmospheric, waiting to be interpreted. It is a planet that demands we think differently about time, civilization, and the forces that shape planetary history. The oceans cover more than 70% of Earth's surface, a vast enigmatic expanse that has long concealed the planet's deepest secrets. Beneath the rolling waves, beneath the lightless depths where sunlight cannot penetrate, lie terrains as varied and complex as any continent, mountain ranges, canyons, and plains, formed over millions of years. Yet these submerged worlds remain largely unexplored. Even the most sophisticated sonar mapping has only scratched the surface, revealing anomalies that defy easy explanation. Massive geometric structures, strange mounds, and patterns inconsistent with natural formations appear scattered across the seafloor, hinting at histories we cannot yet fully comprehend. Consider the Mariana Trench, the deepest known part of the world's oceans. In its crushing depths, pressure exceeds 1,000 times what we experience at sea level. Temperatures hover just above freezing, and darkness is absolute. Yet sonar scans have revealed mysterious shapes, angular forms, ridges, and regular grids that seem deliberate rather than natural. While geologists attribute some of these features to tectonic activity, sediment deposition, or volcanic action, their precision, orientation, and repetition are difficult to explain without considering the possibility of intelligent design. Could these submerged formations be the remnants of civilizations long erased by time, erosion, and the relentless movement of ocean currents? The deep ocean is an extraordinary environment for preserving evidence, paradoxically both destructive and protective. On the one hand, the immense pressure, volcanic activity, and shifting tectonic plates erode or bury anything left exposed. On the other hand, the extreme cold, darkness, and isolation slow decay, preserving materials that would otherwise disintegrate on the surface. Organic structures decompose slowly, metals corrode at reduced rates, and sediments accumulate over relics, protecting them for millennia. In theory, structures or artifacts placed at these depths could survive far longer than anything on land, yet remain invisible until detected by precise sonar or deep-sea exploration. Some of the anomalies discovered in these depths suggest patterns that are almost impossible to explain through natural processes alone. Large mounds with uniform spacing, angular cuts in underwater ridges, and symmetrical shapes recurring across thousands of square kilometers raise questions that traditional geology struggles to answer. Nature is remarkably capable of creating patterns, but rarely with the precision and regularity that suggest intentionality. While some of these formations might be explained as basalt columns, tectonic fractures, or coral growth, the sheer number and consistency of anomalies hint at another possibility, that the oceans may conceal the echoes of intelligence, erased by eons yet preserved beneath layers of sediment. Beyond physical formations, the deep oceans may harbor chemical anomalies that hint at ancient activity. Unusual concentrations of metals, isotopic irregularities, and sediment layers inconsistent with natural deposition suggest localized interventions. If ancient civilizations once manipulated their environment, whether for energy production, resource extraction, or settlement, These traces could survive for millions of years beneath the sea. Metals such as copper, nickel, and platinum, when found in unusual concentrations or embedded in sediment layers that predate humans, challenge conventional explanations. They may represent tools, machinery, or remnants of industrial processes that have been buried and preserved in the deep ocean's unique condition. The mystery of the deep ocean becomes even more compelling when considering the ocean's role in erasing history. Currents, tides, and storms move vast amounts of sediment across the seafloor, covering and uncovering areas unpredictably. Subduction zones and tectonic activity recycle oceanic crust, dragging sediments and any embedded artifacts into the mantle. Entire coastal civilizations could vanish beneath the waves within centuries, while evidence of their existence dissolves over millennia. Yet despite this erasure, the sonar anomalies persist, stubbornly hinting at structures, roads, or energy grids once built by unknown hands. Some researchers have suggested that these deep-sea formations may represent a form of lost urban planning, cities or infrastructure buried under thousands of meters of water and sediment. The size and spacing of anomalies sometimes resemble roads, terraces, or large geometric platforms. The precision with which certain ridges align and the symmetry observed in sonar scans challenge naturalistic explanations. Could these formations be the remains of civilizations that predated humans, submerged due to rising seas, tectonic shifts, or catastrophic events? The possibility, though controversial, cannot be dismissed outright. Hydrothermal vents and undersea volcanoes further complicate the picture. These environments create mineral-rich deposits that sometimes take on unusual forms, forming chimneys, mounds, and pillars that might appear artificial at first glance. Yet even after accounting for these natural features, certain anomalies remain inexplicable. Linear structures, grids, and patterns recurring in multiple locations defy the randomness expected from natural processes. The deep ocean, with its combination of preservation and destruction, acts like both a vault and a tomb, hiding relics while leaving subtle hints for those willing to search. Consider also the implications of undersea archaeology for Earth's ancient history. If civilizations existed millions of years ago, rising seas, tectonic shifts, and ice ages could have submerged vast regions of their territory, erasing traditional land-based evidence. Coastal settlements, energy production sites, and agricultural networks could now lie buried beneath the ocean floor, detectable only through sonar, submersibles, or chemical analysis of sediments. The ocean may preserve evidence that land-based geology has erased entirely, providing a critical window into civilizations that history forgot. Even the most mundane anomalies hint at a deeper pattern. Regularly spaced mounds, straight ridges intersecting at right angles, and clusters of uniform shapes appear across thousands of square kilometers. These patterns suggest intentional design, planning, and perhaps even large-scale engineering. Nature is capable of symmetry, but repeated regularity at this scale, especially in multiple oceanic locations, is difficult to explain through purely geological means. Could these be remnants of an intelligence that once mastered the oceans, building structures capable of withstanding the planet's environmental forces, only to be erased over millions of years? The oceans also preserve chemical traces that may tell the story of ancient civilizations. Unusual concentrations of metals, isotopic anomalies, and sedimentary patterns inconsistent with natural deposition suggest that energy-intensive activities occurred. Ancient reactors, metalworking, or other industrial processes could have left detectable chemical signatures embedded in the sediment layers. If a civilization existed during a time when sea levels and land masses differed dramatically from today, its remnants might now be scattered across the deep oceans, preserved under layers of silt and rock, silently waiting to be discovered. Exploration of these depths is ongoing. Sonar mapping continues to reveal unexpected patterns. Submersibles investigate anomalies, and chemical analyses of sediments uncover irregularities in isotopic ratios. Each new discovery adds pieces to a puzzle that may extend back millions of years. The ocean, though vast and hostile, is a repository of history that land alone cannot provide. What survives is faint, cryptic, and scattered, but it is enough to suggest that Earth has experienced repeated cycles of intelligence, technology, and erasure. The deep ocean reminds us of a fundamental truth: civilizations are fragile, even when advanced. Rising seas, shifting tectonics, and environmental forces can obliterate every trace of a society, leaving only subtle patterns and chemical footprints. Yet even in the most extreme conditions, the planet preserves whispers of history. These anomalies hint at worlds that existed, flourished, and vanished before humans ever walked the Earth. They challenge our assumptions about the uniqueness of humanity, the permanence of achievement, and the fragility of intelligent life. Ultimately, the mysteries of the deep ocean are part of a larger narrative. Earth may have hosted civilizations that have been entirely erased by geological, chemical, and environmental forces. Sonar anomalies, unusual sediment chemistry, and unexpected formations provide clues that intelligence once interacted with the planet on a large scale. Whether these are remnants of industrial activity, settlements, or environmental manipulation, they suggest that history extends far beyond the familiar timeline of human civilization. The ocean preserves evidence that is simultaneously elusive and compelling, offering tantalizing hints of intelligence that has long disappeared, leaving only traces to be interpreted by those daring enough to look. Antarctica is a world of extremes. Vast, frozen deserts stretching for thousands of miles, a surface buried beneath miles of ice, and temperatures that plummet far below what humans can endure. Today it is a barren, inhospitable continent, a place where life clings to existence only in the most marginal forms. Yet beneath this frozen expanse lies a hidden history, one that could rewrite our understanding of Earth's past. Radar scans, ice-penetrating satellites, and exploratory expeditions have revealed anomalies beneath the ice structures, formations and patterns that defy simple geological explanation. These buried secrets hint at civilizations, or at least activity, that predate human memory by millions, perhaps even hundreds of millions of years. The ice sheets covering Antarctica act as both preserver and eraser. They protect what lies beneath from erosion, wind, and biological decay, yet they also obscure and compress, hiding everything from view. Radar and satellite imaging have detected geometric patterns buried under miles of ice, linear formations, circular depressions, and regular grids that appear unnaturally precise. These anomalies are scattered across the continent, sometimes in clusters, sometimes isolated, but their consistency suggests more than random geological processes. Some researchers argue these could be natural features, shaped by glacial movement or volcanic activity, but the alignment, scale, and recurrence of certain structures hint at deliberate design. Could these be remnants of ancient settlements, energy grids, or even research outposts from civilizations long vanished? The age of these anomalies is staggering. Ice cores from Antarctica reveal layers dating back hundreds of thousands, even millions of years. Some of the buried formations appear to predate the most recent ice sheets, suggesting they existed before the continent became a frozen wasteland. If intelligent life existed on Earth before humans, these structures could represent the remnants of activities that were preserved by ice after environmental collapse. Unlike oceans where currents and subduction recycle the crust, Antarctica's ice shields what remains, keeping it hidden yet intact, offering a rare glimpse into a past that has been erased almost everywhere else. Even more intriguing are the chemical signatures detected in these buried layers. Unusual concentrations of metals, isotopic anomalies, and evidence of heat or energy release suggest that processes beyond natural geology may have occurred. Some formations contain traces of elements in ratios consistent with industrial activity, chemical manipulation, or energy generation. These traces are subtle but persistent, hinting that Antarctica may have once hosted activity far beyond simple survival activity that left detectable fingerprints even beneath miles of ice. The possibility of ancient civilizations in Antarctica challenges everything we assume about history. Today we see it as a frozen wasteland, but during the distant past it may have been temperate, covered in forests, lakes, and rivers. Fossil evidence shows that Antarctica was once home to a diverse range of life, including forests populated by conifers, ferns, and even flowering plants, as well as large reptiles and amphibians. If intelligent species existed, these conditions would have provided abundant resources and habitats for development. The ice, which now hides everything, was once water, soil, and forest, a landscape capable of supporting complex life and perhaps even civilization. Radar imaging has revealed anomalies beneath the ice that are strikingly geometric, straight lines extending for kilometers, sharp angles forming grids, and circular depressions that could be foundations or collapsed structures. Natural processes can create patterns, but rarely with such regularity over vast distances. Some anomalies resemble terraces or platforms, leading researchers to speculate that they could be the remnants of settlements, ceremonial sites, or energy generation facilities, while definitive evidence remains elusive. The very existence of these formations suggests that Antarctica may preserve relics of activity from a period when the continent was habitable. Ice acts as both shield and time capsule. Layers of ice accumulate slowly, compressing and preserving whatever lies beneath. Sediments, chemical deposits, and even fossils become locked in frozen archives, shielded from erosion and decay. If ancient civilizations existed, ice could have protected tools, structures, or chemical traces that would have otherwise been destroyed by geological processes. Radar, subglacial drilling, and seismic surveys offer glimpses into this hidden world, revealing patterns that invite speculation about intelligent activity long before humans appeared. Antarctica also offers insight into the fragility of civilizations in extreme environments. Any intelligent species that might have emerged there would have faced challenges of climate, ice formation, and environmental stability. Rising and falling ice sheets, temperature fluctuations, and shifts in available resources could have forced adaptation, relocation, or collapse. The buried formations we now detect may represent the final remnants of these efforts, traces left behind when civilizations vanished, their cities swallowed by ice, their technologies preserved only in frozen silence. The continent's hidden structures may also have connections to global anomalies, chemical evidence, isotopic irregularities, and unexplained energy signatures found elsewhere on Earth suggest that civilizations capable of altering the environment may have existed in multiple regions simultaneously. Antarctica, preserved by ice, may be one of the few places where physical evidence survives. Its frozen layers could contain materials, structures, or chemical signatures that directly correlate with anomalies found in oceans, deserts, or ancient rock formations, providing a missing link in the broader pattern of intelligent activity that has left only fragments behind. Subglacial lakes in Antarctica add another layer of mystery. Hundreds of lakes remain liquid beneath miles of ice, insulated by pressure and geothermal heat. These lakes are isolated, chemically unique, and preserved for millions of years. If civilizations existed, they could have exploited such lakes for water, energy, or even settlements. The chemical composition of these lakes sometimes shows unusual elements, metals or isotopes, though their origins remain unexplained. Could these hidden bodies of water have preserved evidence of advanced activity, or perhaps even life forms adapted to extreme conditions? The potential is tantalizing and raises questions that conventional archaeology cannot answer. Antarctica's buried secrets also force us to reconsider the passage of time and the erasure of history. Unlike Earth's surface, which is constantly reshaped by erosion, volcanism, and tectonics, ice preserves what it covers, albeit compressed and obscured. Structures that might have vanished elsewhere could survive beneath miles of frozen layers, protected from decay and destruction. The continent is both a tomb and a vault, holding traces of activity that challenge our assumptions about intelligence, survival, and the longevity of civilization. The implications are profound. If ancient civilizations existed on Earth, their remnants may be preserved in Antarctica more completely than anywhere else. Cities, energy systems, or technological installations could lie beneath the ice, invisible to casual observation, yet detectable through radar, seismic surveys, or chemical analysis. The continent may contain the most enduring evidence of intelligent activity that has been erased elsewhere, waiting for exploration and interpretation. These hidden archives, though silent, speak volumes about the potential complexity, ingenuity, and fragility of civilizations long forgotten. Ultimately, Antarctica is a reminder that Earth's history is far more complex than we can see on the surface. The hidden continent may preserve evidence of intelligence, activity, and environmental manipulation that predates humanity by millions of years. Its buried anomalies challenge our understanding of what is possible, showing that civilizations can rise, thrive, and vanish, leaving only subtle traces preserved under ice. And it serves as a warning. Intelligence may emerge repeatedly, flourish briefly, and disappear almost entirely, leaving behind a puzzle that only those willing to look deeply and think boldly can hope to solve. The moon, that pale companion in the night sky, has long been seen as a lifeless satellite, a barren rock orbiting Earth, untouched by the drama of life. But for those willing to look beyond the familiar, it holds secrets that may challenge everything we think we know about history, intelligence, and the persistence of evidence. Unlike Earth with its active geology, oceans, and atmosphere, the moon is a pristine archive. Its surface has remained largely unchanged for billions of years, preserving cosmic collisions, ancient debris, and even fragments of Earth itself in ways that our dynamic planet cannot. If there were ever civilizations that existed before humanity, the moon may hold traces of them, quietly frozen in time, untouched by erosion, ice, or tectonic. One of the most remarkable aspects of the moon is that it functions as a repository for material ejected from Earth. Throughout geological history, asteroid impacts have blasted massive amounts of Earth's crust into space, some of it landing on the moon. Rocks, minerals, and even traces of biological material can survive these journeys, embedded in lunar regolith for millions or even billions of years. In this sense, the moon acts as a mirror of Earth's past, preserving evidence of processes, events, and potentially even civilizations that have long since vanished beneath oceans, ice, and shifting tectonics. The moon's surface is littered with craters, basins, and regolith, all of which act as protective layers. Unlike Earth, the moon lacks an atmosphere capable of weathering its surface, and it has no active tectonics to recycle crust. As a result, artifacts, debris, or unusual chemical signatures can persist for astonishing spans of time. If civilizations existed on Earth before humanity, and if their activity left behind any material that was ejected into space, whether through natural impacts, mining, or energy-intensive processes, those fragments could survive on the moon in a virtually pristine state. Unlike Earth, where history is erased by erosion and tectonics, the moon acts as a cosmic vault, preserving what Earth cannot. Meteorites from Earth found on the moon could contain chemical evidence of industrial activity, isotopic anomalies, or even traces of technology that no longer exist on Earth. Just as the Oklo reactors and ice core anomalies hint at ancient intelligence, lunar deposits could hold complementary evidence, preserved across eons. Even if civilizations were completely erased from the surface of Earth, their fingerprints might still be detectable in lunar rock, frozen in place, waiting for us to recognize them. The moon, in essence, is a time capsule that captures the planet's history in a way no other location can. The possibility that the moon preserves evidence of ancient activity becomes more compelling when we consider its geological stability. While Earth constantly recycles its crust, the moon remains largely static. Its craters, basins, and highlands have survived for billions of years, recording cosmic collisions and surface changes in exquisite detail. If fragments of Earth or objects ejected from ancient civilizations landed on the moon, they would be insulated from the forces that erase history on our own planet. Even delicate chemical signatures or isotopic anomalies could survive, preserved beneath layers of dust and regolith, providing a record that humans might one day read like a ledger of lost worlds. Radar mapping, satellite imagery, and lunar exploration have revealed intriguing features that hint at unusual activity. While most formations are naturally explained by impacts, volcanism, or tectonic settling, some anomalies defy easy explanation. Unusual linear features, symmetrical patterns, and structures that appear inconsistent with known geological processes suggest that the moon may hold more than just craters and regolith. Could these be artifacts, remnants of ejected structures, or perhaps the byproducts of energy-intensive processes conducted on Earth billions of years ago? While the evidence is circumstantial, the moon offers a unique environment in which these possibilities can persist for eons, untouched by erosion or atmospheric decay. The moon also provides a lens through which we can understand Earth's early history more clearly. Samples collected during the Apollo missions contain ancient rock dating back over 4 billion years, some of which originated from Earth itself. These rocks preserve isotopic signatures, chemical anomalies, and traces of processes that have long since been erased on our dynamic planet. If civilizations existed during the Precambrian, Permian, or even earlier eras, it is conceivable that fragments of their activity were ejected into space, landing on the moon and remaining preserved. The implications are staggering. The moon may contain the only surviving material evidence of civilizations that Earth's geology has destroyed. The potential for discovery is amplified by the moon's lack of atmosphere and water. These factors mean that material deposited on the surface, or buried just beneath a thin layer of regolith, can survive for billions of years, with minimal alteration. Radiation from the sun, micrometeorite impacts, and cosmic rays do affect the lunar surface, but their effects are predictable and can be accounted for in analysis. Unlike Earth, where soil, water, and wind continuously recycle material, the moon is a stable archive, capable of preserving not just rocks, but also chemical traces, isotopic anomalies, and potentially engineered artifacts. Even the smallest fragments can provide profound insights. A shard of metal, an unusual mineral formation, or a chemical signature inconsistent with natural processes could serve as proof of intelligent activity on Earth long before humans. In this sense, the Moon acts as a library storing records of the planet's past in a way that cannot be replicated on Earth. By studying lunar regolith and impact ejecta, scientists may be able to uncover evidence of industrial processes, energy manipulation, or even the remnants of technology that no longer exists anywhere on the planet itself. The Moon's role as an archive also extends to the broader question of intelligence in the solar system. If Earth has hosted civilizations before humanity, the traces of their activity may not be confined to the planet. Lunar deposits provide a preserved record that complements anomalies on Earth, Mars, and even Venus. By analyzing these materials, we can begin to reconstruct a more complete picture of the cycles of rise and collapse, innovation and erasure that have occurred over billions of years. The Moon is a stable, silent witness to the history that our planet largely forgets, preserving fragments of stories that would otherwise be lost forever. The implications for humanity are profound. If the Moon contains evidence of civilizations that existed long before us, it challenges our assumptions about uniqueness, progress, and survival. It forces us to consider that intelligence may arise repeatedly, flourish for a time, and then vanish without leaving recognizable structures on the planet where it emerged. The Moon may hold answers to questions that Earth cannot provide, acting as a repository for the echoes of life, technology, and ingenuity that have been erased over geological time. Ultimately, the Moon is more than a barren satellite. It is a cosmic archive, preserving fragments of Earth's lost history. Rocks, isotopes, and chemical anomalies may contain the fingerprints of civilizations erased by oceans, ice, tectonics, and erosion. If we are willing to study it with rigor and imagination, the Moon could reveal evidence of life, technology, and intelligence far older than humanity, offering a glimpse into the cycles of creation and destruction that have shaped our planet, and possibly the solar system itself. It is a reminder that even in silence, even in barrenness, history endures, waiting for those who are bold enough to read it. The universe is vast, unimaginably so, containing billions of galaxies, each with billions of stars, many with planets potentially capable of supporting life. Yet when we look up at the night sky, we encounter an eerie silence. Despite the immense probability of life elsewhere, we see no evidence of intelligent civilizations. This paradox, famously framed by physicist Enrico Fermi, asks the haunting question, where is everybody? If life is common, intelligent life should emerge. Why have we detected no signals, no structures, no communications? The silence is deafening, and it has led scientists and thinkers to consider a sobering possibility: the existence of a great filter. The great filter is a theoretical barrier that prevents life from progressing to the point of widespread interstellar colonization or detectable activity. It could occur at any stage: the origin of life, the development of intelligence, the mastery of technology, or the survival of civilizations long enough to avoid self-destruction. The more we study Earth and the anomalies within our own history, the more the great filter becomes tangible. It suggests that civilizations may rise, manipulate their environments, harness energy, and then vanish, leaving little to no trace. The evidence we have seen in ancient ice cores, uranium deposits, oceanic anomalies, and planetary satellites hints at the possibility that the great filter may lie not in the emergence of intelligence, but in the survival of that intelligence across geological timescale. Consider the evidence from Earth itself. Across hundreds of millions of years, the planet has experienced cataclysmic extinctions, sudden chemical shifts, and environmental upheavals. Civilizations, if they existed, could have emerged and vanished multiple times, erased by the very forces that sustain life. Nuclear anomalies, out-of-place artifacts, and chemical fingerprints suggest that intelligence may have arisen and manipulated energy long before humans, only to be extinguished by circumstances beyond its control. The great filter in this sense is not hypothetical. It may be a pattern embedded in Earth's geological and chemical record, an almost invisible force shaping the fate of all civilization. The Fermi paradox gains new weight in light of this evidence. If intelligence is transient, if civilizations are routinely destroyed by planetary-scale events, then the universe's silence becomes less mysterious. Advanced life may be common, but longevity is rare. Civilizations may exist for thousands or millions of years, only to be extinguished before they can communicate across interstellar distances. The anomalies on Earth, the preserved evidence on the Moon, the buried secrets of Antarctica, the chemical and isotopic fingerprints across oceans and ice, all suggest that intelligence can rise, flourish, and vanish repeatedly. The universe then is filled with the ghosts of civilizations that once were but are no longer. This perspective casts our own civilization in a precarious light. Humanity has achieved unprecedented technological progress, yet our tenure on Earth is still brief in geological terms. We manipulate energy, alter ecosystems, and generate chemical changes visible from space, much like the civilizations hinted at by Oklo, ice cores and oceanic anomalies. If the patterns revealed by these anomalies are a guide, then we too may face the great filter. The same forces, environmental collapse, technological self-destruction, or unforeseen planetary changes that ended previous civilizations could threaten our survival. The silence we detect in the cosmos may be a warning. Intelligence is ephemeral, and survival is far from guaranteed. The anomalies across Earth, the Moon, Mars, and Venus suggest that intelligence is not unique to humans, nor is it necessarily permanent. The repeated emergence and disappearance of civilizations may be a universal principle, a cosmic rhythm encoded into the history of planets capable of sustaining life. The Fermi paradox is thus not a question of absence, but of timing. Civilizations may rise and fall in cycles, their traces preserved only in subtle chemical, geological, or physical signatures, almost entirely erased from the historical record. When we gaze at the stars, the silence is not emptiness, it is the cumulative echo of countless civilizations that came and went, leaving only whispers in the geological and astronomical record. The great filter, then, may operate on multiple scales. Some filters may prevent life from emerging at all. Others may allow life to arise but destroy civilizations before they reach technological maturity. Earth's history suggests another kind of filter: longevity. Civilizations may be able to harness energy and manipulate their environment, yet fail to survive the long-term consequences of their actions. Nuclear anomalies, chemical spikes, and geological evidence point to environmental manipulation that could have triggered collapse. The filter is not a singular event. It is a combination of forces, from planetary shifts to self-inflicted damage, that ensures few, if any, civilizations persist across geological time. The implications for our understanding of intelligence are profound. The evidence suggests that intelligence may not guarantee survival, nor does technological mastery confer permanence. Civilizations can manipulate energy, alter ecosystems, and achieve complexity, yet still be erased, leaving only faint traces detectable by future observers. The anomalies we see on Earth, Mars, Venus, and the Moon hint at civilizations that may have reached remarkable levels of sophistication, only to vanish due to planetary instability, environmental collapse, or unforeseen catastrophes. The Great Filter is both a pattern and a warning, a principle of cosmic caution that underscores the fragility of intelligent life. It also reframes the search for extraterrestrial intelligence. The universe may be teeming with planets that have hosted intelligent species, yet the signals we seek, radio transmissions, megastructures, or interstellar communication, may be fleeting. Civilizations may rise and fall within geological moments, leaving behind only subtle chemical or physical anomalies. The anomalies on Earth provide a template for what to look for: traces that survive environmental collapse, evidence that persists despite the erasure of physical structures, and chemical or isotopic signatures that hint at intelligence long gone. Ultimately, the Great Filter and the Fermi paradox compel us to confront our place in the cosmos. The anomalies we detect, from uranium deposits to ice core spikes, from deep ocean structures to lunar archives, suggest that intelligence may have arisen before us and failed. Our silence among the stars may not indicate isolation, but the common fate of civilizations throughout history. Earth's geological record, Venus's lost oceans, Mars' vanished habitats, and the Moon's preserved fragments together tell a sobering story. Intelligence is fragile, civilizations are ephemeral, and the universe remembers little of what once was. In this context, humanity faces a choice. The patterns revealed by ancient anomalies are both warning and lesson. The survival of our civilization depends on understanding the forces that extinguished those that came before. Climate change, nuclear technology, ecological imbalance, and planetary scale disruption may represent our own great filter. The evidence embedded in Earth's rocks, oceans, ice, and satellites is not merely academic, it is a record of trials, failures, and near extinctions. By studying it carefully, we may glimpse the thresholds we must avoid, the forces that end civilizations, and the strategies that might allow intelligence to endure in a universe that has seen it rise and fall countless times. The universe's silence is thus no longer a mystery, but a reflection of history. The great filter may be the reason why stars appear empty, why the cosmos does not broadcast civilizations, and why the evidence we find is subtle, fragmented, and enigmatic. It is a challenge and a warning. Intelligence may be transient, but careful observation, study, and understanding of past anomalies may provide a roadmap to avoid extinction. The Fermi paradox is not a question to be dismissed. It is a mirror, reflecting what happens when civilizations rise, thrive, and vanish, leaving only traces that demand interpretation and imagination. As we step back from the vast tapestry of evidence, a picture begins to emerge, one both awe-inspiring and sobering. Earth, and perhaps the broader solar system, appears to have been host to civilizations that existed long before humans walked the planet. From the enigmatic natural nuclear reactors of Oklo to chemical anomalies in ice cores, from deep ocean formations to Antarctica's buried structures, and from lunar archives to vanished Martian and Venusian habitats, the traces are fragmentary yet compelling. They suggest a repeated pattern. Intelligence rises, harnesses energy, manipulates its environment, and ultimately disappears, leaving only subtle echoes for those who follow. The cycle is ancient, vast, and humbling, reminding us that civilizations are transient, no matter how advanced. The cumulative evidence compels a profound re-evaluation of history. Human civilization often assumes a linear trajectory. Intelligence emerges, technology progresses, and our achievements accumulate. Yet the anomalies scattered across Earth, the Moon, Mars, and Venus hint at a far more complex timeline. Intelligence is not new, nor is its appearance unique to humanity. Civilizations may have arisen multiple times, across different planets, only to vanish before leaving visible monuments. What survives is rarely obvious. A chemical signature, an unusual isotope, a buried formation, a fragment of rock, or a subtle anomaly preserved against impossible odds. These remnants are all that remain of civilizations that once mastered energy, adapted to their environments, and yet ultimately failed to endure. One of the most striking lessons from these ancient patterns is the fragility of intelligence. Civilizations that achieve remarkable technological sophistication are not immune to extinction. Environmental collapse, planetary instability, or the unintended consequences of energy manipulation can erase entire civilizations, leaving only whispers of their existence. The Oklo reactors demonstrate the mastery of nuclear energy long before humans, yet the evidence persists only as isotopic ratios in stone. Deep ocean anomalies hint at vast constructions now buried beneath kilometers of sediment. Antarctica conceals geometric formations under miles of ice. Mars and Venus may preserve the faint remnants of lost civilizations, erased by climate change and planetary upheaval. Across all these examples, the pattern is consistent. Intelligence is ephemeral, and survival is never guaranteed. This recognition forces us to confront humanity's own place in the universe. We are the latest in a possible sequence of civilizations, rising on a planet that has hosted intelligence before. The anomalies in Earth's geological record act as both warning and guide. Ice cores reveal sudden chemical spikes, suggesting environmental manipulation and potential collapse. Uranium deposits hint at energy harnessed with precision. Oceanic formations demonstrate that large-scale construction can be erased over millennia. If civilizations before us could disappear without leaving clear monuments, what hope do we have of enduring? The great filter, as discussed in the context of the Fermi paradox, looms as a shadow over human civilization. Our survival depends not just on ingenuity, but on foresight, restraint, and a deep understanding of the forces that threaten longevity. The evidence also challenges our perception of progress and uniqueness. Humanity often sees itself as exceptional, the first intelligent species capable of altering the planet on a global scale. Yet, Earth's deep history suggests otherwise. Intelligence may arise whenever conditions allow, yet permanence is rare. Civilizations may emerge, manipulate their environment, and vanish, their technological achievements erased, leaving only subtle chemical, geological, or physical traces. This perspective humbles our sense of importance while emphasizing the responsibility inherent in intelligence. To survive, we must learn from the patterns of rise and fall embedded in Earth's history, even when the actors behind those patterns are long gone. The anomalies across planets also hint at the universality of these cycles. Mars, once temperate and capable of supporting life, may have hosted intelligent species whose traces now lie buried beneath dust and sediment. Venus, now a scorched, inhospitable world, may have once been a paradise, preserving chemical and geological signatures of vanished civilizations in its upper atmosphere and surface formations. The Moon, largely inert and geologically stable, may harbor fragments of Earth's lost civilizations, preserved as ejected rocks and isotopic anomalies. When examined together, these planetary records suggest that intelligence is not isolated, but recurring, and that extinction is a universal risk, not limited to a single world. Studying these patterns also reframes how we interpret anomalies on Earth. Out-of-place artifacts, unusual isotope ratios, geometric formations, and chemical spikes may not be curiosities or coincidences. They may be the remnants of civilizations that existed millions of years before humans. Recognizing these anomalies requires a willingness to challenge assumptions, to interpret subtle evidence, and to imagine possibilities far beyond conventional history. The planet itself becomes a record keeper, preserving intelligence in ways that are difficult to read, yet impossible to ignore once patterns emerge. The reflection also extends to ethical and existential considerations. If civilizations rise and vanish repeatedly, what lessons can humanity draw for its own future? Technological advancement is not inherently safe. Harnessing energy, altering ecosystems, and manipulating the environment carries risks that, if mismanaged, may lead to collapse. The traces left by ancient civilizations, chemical, geological, or structural, serve as warnings. They remind us that longevity requires foresight, sustainability, and respect for planetary systems. Intelligence alone does not guarantee survival. Understanding, planning, adaptation do. Moreover, these patterns raise questions about cosmic perspective. If intelligence has arisen repeatedly, the universe may be filled with the echoes of civilizations that once were, yet have vanished without a trace. The silence we observe in the cosmos may not indicate absence, but the ephemeral nature of intelligence itself. Civilizations capable of interstellar communication may exist, but the forces that limit longevity may prevent them from leaving detectable signals. The Fermi paradox, then, is not merely a curiosity, it is a reflection of patterns visible in our own planetary record. The rise and fall of civilizations is a rhythm encoded in geology, chemistry, and planetary evolution. The most profound lesson, perhaps, is the interconnectedness of intelligence and environment. Ancient anomalies demonstrate that civilizations are inseparable from the planets they inhabit. Environmental manipulation, energy use, and planetary systems interact in ways that can either sustain or destroy civilizations. Earth, Mars, Venus, and even the Moon provide records of these interactions, showing that planetary scale forces are indifferent to intelligence. Survival requires understanding these forces, respecting limits, and recognizing that the lessons of the past are not abstract. They are encoded in rocks, ice, oceans, and celestial bodies. Finally, the reflection on these cycles emphasizes curiosity, exploration, and interpretation. Humanity has the unique opportunity to study anomalies preserved across the solar system, from uranium deposits to ice cores, oceanic formations to lunar rocks, and from buried Antarctic structures to planetary atmospheres. Each fragment, chemical signature, and geological irregularity is a clue, a whisper from civilizations that may have existed long before us. To study them is to engage with history on the grandest scale, to recognize patterns of rise and collapse, and to glean lessons that may help us navigate our own civilization's fragile existence. In conclusion, the cycles of intelligence, rise and disappearance are a recurring theme across time and space. Earth's anomalies, the Moon's archives, the vanished habitats of Mars and Venus, and the hidden structures beneath ice and oceans together tell a story of repeated emergence, fleeting brilliance, and ultimate erasure. Humanity stands at the latest point in this continuum, aware of its fragility, yet possessing the capacity for foresight and preservation. The lessons of the past are clear. Intelligence is not eternal, survival is rare, and the universe is filled with both potential and peril. By studying anomalies, interpreting subtle evidence, and learning from the patterns etched into planets and satellites, we can hope to endure where others have vanished. History, hidden in stone, ice, and celestial archives, offers a warning, a lesson, and perhaps a path forward. As we step back from the vast panorama of Earth's deep history and the anomalies scattered across the solar system, a humbling truth emerges. Intelligence, civilization, and technological mastery are far more fragile than we often imagine. Across billions of years, life on Earth has flourished, evolved, and vanished repeatedly. From the enigmatic chemical spikes in ice cores to the natural nuclear reactors of Oklo, from buried Antarctic structures to mysterious formations in the deep ocean, and from lunar archives to vanished habitats on Mars and Venus, the evidence suggests a recurring pattern. Civilizations may rise, harness energy, manipulate their environments, and leave behind remarkable achievements, only to be erased by the relentless forces of time, planetary upheaval, or unforeseen catastrophe. What survives are whispers, faint chemical, geological, or physical signatures that demand interpretation, imagination, and idiocy. This pattern forces us to rethink the story we tell about ourselves. Human civilization, with its remarkable technological progress, may be just the latest chapter in a history of intelligence that stretches back millions of years. The Earth and its neighboring planets may have been host to civilizations that achieved extraordinary mastery over their worlds, yet vanished without leaving recognizable cities, monuments, or technologies. The anomalies preserved in rocks, ice, oceans, and celestial bodies are fragments of these lost worlds, a record not of failure alone, but of possibility, the potential for intelligence to emerge, thrive, and interact with the planet on a profound scale. The lessons are as urgent as they are profound. Intelligence alone does not guarantee survival. The civilizations hinted at by these anomalies demonstrate that mastery of energy, technology, and environment carries inherent risks. Environmental collapse, unchecked energy use, or planetary shifts can erase even the most sophisticated societies. The Great Filter, visible in Earth's history and reflected in the Fermi paradox, underscores the fragility of civilizations across the cosmos. Longevity is rare, and survival requires not only ingenuity but foresight, restraint, and a deep understanding of the systems that sustain life. The echoes of past civilizations are warnings as much as they are evidence, lessons we cannot afford to ignore. At the same time, the evidence invites awe and wonder. The Moon preserves fragments of Earth's past, potentially encoding traces of ancient intelligence. Mars and Venus reveal that planets capable of supporting life may experience cycles of habitation, technological emergence, and catastrophic collapse. The deep oceans and Antarctica act as hidden archives, shielding evidence of civilizations that existed long before humans. Even in the vast, cold silence of space, the solar system itself may record the history of intelligence, waiting for those with the knowledge, tools, and curiosity to read it. These discoveries remind us that history is not a linear narrative, but a layered, complex story of emergence, adaptation, and erasure. Ultimately, the conclusion is both sobering and inspiring. Humanity is a part of this continuum, a civilization capable of unprecedented achievement, yet acutely vulnerable to forces both internal and external. By studying the traces of what came before, by interpreting the anomalies that survive in ice, rock, oceans, and celestial archives, we gain insight not only into the past, but into our own potential future. We are custodians of intelligence, inheritors of a pattern that has repeated countless times across the cosmos. Our challenge is to endure, to act with awareness, and to ensure that the story of intelligence does not end with us. The universe is full of whispers, subtle evidence of civilizations that have risen and fallen, and in listening to them, we learn the most crucial lesson of all: survival is not guaranteed, but it is possible for those who heed the echoes of the past and act wisely in the present.